What's up, people? What's up? What's up? First of all, I would like to apologize for coming super duper late, 20 minutes almost. I'm really sorry for that. There were a lot of technical issues because, it's early in the morning. So, really sorry for that. I hope that I didn't take up too much of your time. But yes, anyways, we are starting now without wasting much more time. We'll get into the session. So, first of all, before we get started, people, I would like to wish you guys all the very best of luck for your exam tomorrow. Whatever you have done for the past 1 year is going to come into fruition, or the result of it is going to come out tomorrow. So all the very best of luck. But yes, once again, a very warm welcome. Sorry for coming late, a lot of technical issues. But yeah, my name is Anoop. This is Vedantu's 9th and 10th English channel. This is the marathon series for physics in this channel. All right, so without wasting much time, we'll get into the topic. Let's not waste much time at all because it's already been a lot of time. It's been already 20 minutes now. Okay, so anyways, what's up? All good? Okay, let's begin. All right, so people, today we'll be doing the marathon series. We'll be doing a lot of questions, about 20-25 questions is what I have in store for you guys. Bhawna Mam would also be joining after some time, not right now. She'll be joining us a little later. And once she's also in, again, we're going to have a blast. We'll make sure to cover all the important questions in today's session. Whatever, again, the past year question paper, sample paper questions, some of the questions which I feel are interesting and something that can be expected in both. Those questions have also been put in this particular session. Now, before we start, guys, I would like to start off this session with a very simple quote. Not a quote, but something that can help you manage your stress a little better, because I know that a lot of you guys at this point of time are finding it a lot difficult to manage everything that is going on. So this is a mantra that I want you guys to follow for the next couple of weeks at least, until your board exam is done. And that is this, guys: I will breathe. I will think of solutions and not the problems. I will not let my worry control me. I will not let my stress levels break me. I will simply breathe and it will be okay, because I don't quit. Now, again, I'm telling you this for one simple fact. A lot of you guys here who are watching this session right now, I'm pretty sure are very well prepared with your content. Like, content wise, you guys are well prepared. Physics, you guys pretty much know all sorts of numericals. You are probably prepared. All the theory of physics, chemistry and bio. But the problem lies is the fact that you guys are not able to manage your stress a little better. Majority of the time, people, half of your marks you end up losing because of your stress, because you're not able to think clearly at that point of time, because your stress is overcrowding, is overshadowing, is basically clouding your judgment, your thoughts. All right, so all you have to do whenever you feel like it's basically getting a little too much, just breathe, stop for a second, take a breather, take a 30-second break, and then go to the question. All right, sounds good? Shall we start? Yeah, please. Absolutely, T-Rex. Let's get started. Give me a oh yeah in the chat box, people, so that we can begin today's session. Let's go. चलो जी, हम शुरू करते हैं. Bhavna auntie will be coming up. Yeah. Bhavna auntie has to get ready. No, it'll take 2 hours for her to get ready itself. All right, that's why I told her, "Aram se come." All right, let's get started. Now, before we get started, this is the schedule for today. You can take a screenshot of this. So we have right now we have this marathon session going off of me. Right after this, we'll have the biology marathon session taken up by Pritesh sir. Right after that, we'll have the chemistry marathon session taken up by Shilpi ma'am, and after that again we'll also be coming live at 4:30 today, all three of us together, Shilpi ma'am, Pritesh sir and me, to solve your doubts as well. So that will be around 2 hours of doubt solving. Right now we'll be just teaching, we'll be doing a lot of questions. Later on in the evening we'll also be doing a lot of doubt solving as well. We've already put out the Google forms for your doubts. You can fill it out. You can find it in the community page. Fill out your doubts, whatever doubts you have. We'll get that sorted in that 2 hour time. All right. So with that said, people, let's go on to the 2 markers, shall we? All right. So again, I have divided the questions into 3 categories. We'll start with the 2 markers, then the 3 markers, and then finally we'll end with the 4 markers. So here is the first 2 marker question. The question is, in the figure below, identify the poles marked as P and Q. Which of these is the north or the south pole, and give reason for your answer. This particular question was asked in CBSE 2010 board exam. A simple 2 mark question. So put it down in the chat box, guys. There are 2 poles given. Which of this is the north pole, which of this is the south pole, or which among them is the north and south pole respectively? Put it on in the chat box very quickly, guys. Come on. Do Nagin answer. Yeah. Towards the end, pakkada. Yeah. Oh, Rohit, that is the most lamest joke Abhishek sir cracked on that data, by the way. Alright, let's go. Quickly, guys, quickly. Pakka, 100%, 200%. Shall we lock the answer? क्या बात है बेटा जी, क्या बात है? Absolutely. Arindam, it's not that. Both of these are north pole, because if you think about poles for that matter, north pole is where the magnetic, when you talk about north pole, that is where the magnetic field lines are originating, are starting. South pole is where the magnetic fields are ending up in. And here, if you look at it, in both these cases, the magnetic field lines are going away, and hence both of these are north pole. Now you might be wondering, sir, how can this be of the same magnet? It is not mentioned that it is of the same magnet. This is one separate magnet. This is another magnet. It is not mentioned that both of them are of the same magnet. Alright, so for all those who are confused, look at the magnetic field lines. Both of them are going away from the magnet, which means that both of them are the north pole. Fantastic. Brilliant start. Alright, let's go on to the second question. Now don't worry, guys, I'll be putting down the notes of this right after the session. It will be uploaded by 12 p.m. max, so you can download the notes and go through the entire thing later, so don't worry about that. Alright, here's another one. The following table gives the value of electrical resistivity of certain materials. Which one is the best conductor of electricity out of the 3? There are 3 given. One is of copper, one is silver, and the other is Constantine. All right, Constantine, it's not Constantine, it's Constantine. All right, now electrical resistivity respectively are 1.6 into 10 to the power of minus 8 ohm meter, 1.6 into 10 to the power of minus 8 ohm meter for silver as well, and Constantine has an electric resistivity of 49 into 10 to the power of minus 8 ohm meter. Which of them is the better conductor or the best conductor in this case? Pakka. Look at the resistivity. 100% sure it's only silver. 100% sure it's only silver. Now I want you guys to see, I know that technically speaking, yes, silver is a better conductor, but in this question where both copper and silver has been given the same exact resistivity value, which is the best conductor? Exactly, both people, both would be the answer. Now technically speaking, its copper is around 1.62 to 6.4 is what 1.62 to 1.64. Silver on the other hand is 1.6. But here in this question, since both of them have been given the same value of resistivity, just going by this, the answer would be both, because both have the same value of resistivity. Now technically speaking, according to what we know, according to the law of nature, silver is a much better conductor than copper. But in this question, since they both have been given the same value of resistivity, you have to say that both of them are the best conductors in this case. Got it? I hope it makes sense, people. Please, again, do not make silly mistakes like this, because it's very straightforward. There's nothing more to think about it. It's very straightforward. Make sure you check the values and write it. All right. Sometimes according to the question also, you might have to, go according to that. All right. Next question from 2009 CBSE board exam. All right. The question is, A lamp rated at 100 watts at 220 volt is connected to the main supply or mains electric supply. What current is drawn from the supply line if the voltage is 220 volt? You have to find out what is the value of current. How much current is drawn is what is the question. A very simple question again. Go ahead, put it down in the chat box, people. I want all of you guys to put it down. 5 by 11 pakka 0.454. Arre, what calculation now, Uday ji? All right. See, Ajay, that is the question. See, the question is very ambiguous in the sense they have not mentioned, they have not given whether it's 2 or 1. But clearly, if you look at the values, if you just go by the values, nothing else, if you just go by the values given, both of them have the same value. So, if both of them have been given the same value, how can you say that one is not better than the other or one is better than the other, right? They're both given the same values. And when you talk about resistance, what is resistivity? Resistivity is nothing but the resistance of a material of equal length or unit length and unit cross section, right? 1 meter length or 1 centimeter length and 1 centimeter square area or 1 meter square area. That is what is resistivity. So length and area both are same. So how can you say that one is better than the other if the value of resistivity given is also exactly the same? Got it? That is what? Mathematically speaking. Alright. Okay, put it on the chat box, people. Quickly, what is the answer? 0.45. Pakka. Shall I log the answer? Fantastic, fantastic. Very simple question again, people. Please give it a, make sure that you write on the given data first. Alright. So power is given as 100 watts. Awesome. Alright. Voltage is given as 220 volts. You need to find out what is the current drawn from the supply. So what is the formula? P is equal to V into I. Simple. Substitute the values. P is given as 100 watts. Voltage is given as 220 volts into I. So what is I equal to? 100 divided by 220. 0 gets cancelled. 2 5s are 10. 2 11s are 22. 5 by 11. Simple. If you want to convert it to decimal points, that's also absolutely fine. 5 by 11, what is the value? 0.45. Absolutely correct. 0.45 amperes. That's all. Super awesome, super awesome. All right, people, with that said, let's go on to the next question. Fourth question once again. CBSE 2013 board exam. The question is, N resistors, each of resistance R, are first connected in series and then connected in parallel. What is the ratio of the total effective resistance of the circuit in series combination and in parallel combination? Fantastic question. The fact is, I have already done this question at least 3 to 4 times in the past. The top 20 questions in the marathon, in the sprint X series, we have done the exact same question several times. So go ahead and put it on the chat box, guys. Absolutely fantastic. Absolutely fantastic. For all those who are wondering how to answer this question, I'll tell you how to do this. Now, first of all, guys, please understand that when you have n number of resistors and you've connected them all in series, the equivalent resistance for series connection is N into R, where N is the number of resistors. For example, let's say that I have 100 resistors, each of 2 ohms connected in series. 100 resistors, each of 2 ohms connected in series. In that case, if I want to find out the equivalent resistance, what's the formula? RS, which is nothing but equivalent resistance, is N into R. So for series connection, it's N into R. In the same case, when you talk about parallel connection, if you have parallel connection, in parallel connection, on the other hand, again, if you have n number of resistors, 100 resistors, each of 2 ohms, then the equivalent resistance is what? It is going to be R by N. So RP, which is equivalent resistance in parallel, is going to be R by N. Simple. Now all you have to do is find out the ratio. What is the ratio? R is by RP. Here they have clearly mentioned series combination and parallel combination. So series would come in the numerator, the parallel would come in the denominator. So this is going to be what? NR divided by R by N. N will go to the numerator, or if you find this a little confusing, which I'm sure a lot of you guys do for some reason, for all those who are confused about this one, so this can be written as N by R into, my bad people, so N into R into N by R. So from here, R gets cancelled. So what are you left with? N square is to 1 or n square by 1. Got it? Easy question, super easy. Now again guys, please make sure that you remember this, because this is a very common kind of question that has been, if you look at the sample papers, if you look at the reference books and all that, this is a question that has been repeated a lot of times in a lot of different publication. Very important one at that. So make sure you remember this. It is n square is to 1 or simply n square. All right, fantastic job people, fantastic, because I was able to see the answers in the chat box in the first 3 seconds itself. Absolutely awesome. Keep up the good job guys. Let's go on to the fifth question now, shall we? The fifth question, and yet another easy one, but this I'm pretty sure a lot of you guys will go wrong in. The question is this: out of two wires X and Y shown below, which one has the greater resistance? Justify your answer. All right, I'm pretty sure a lot of you guys will go wrong on this. Prove me wrong otherwise. Prove me wrong. Let's go. Two wires, one is of length L, the other one is twice the length, is going to be twice the length of wire A. If that is the case, which one would have a greater resistance is the question. Let's go. Hi Simranji, I've been very busy. But yeah, why? Pakka? Why? 100%. Pakka? 100%. Why or why? Why is the question. Yes, why is the answer, but why? That is the question. Why or why? Because length is directly... Okay, you guys have proved me wrong. I'm wrong. Fantastic. Can I get a high five for this one? Because I thought a lot of you guys will make mistake in this. I knew you... It's like, how do I say this? I knew you would get it right. It's just simply, lighting that fire so that you guys will answer it. But high five now. Fantastic job. Alright, so answer of this question guys was very simple again. Please, if you remember this, R is equal to rho into L by A. This is the formula for resistance, right? Resistance is equal to resistivity into length of the conductor divided by the cross-sectional area. If that is the case, since the length of the second wire, that is wire Y, is double the length of wire X, which means that what? R is directly proportional to L. Now here for wire Y, the length is double. If the length is double, the resistance also will become double. Because why? Length and resistance are directly proportional to each other. So the resistance of Y will also become twice or 2 times more than the resistance of wire X. Why? Because the length is doubled. Please remember this simple formula. You need to know this because you have a lot of numericals and you also have a lot of, relationships that you have to show in this particular kind of questions. All right, moving on to the next question, people. That is the end of this one. Again, you can see the answer right here. Where is the answer for this one now? It's given right here. So please make sure you download the notes later and refer to it if there is any sort of confusion. All right, guys, let's go to the next question now. Sixth question, shall we? Sixth question. Hi, Bhavishya, what's up? Now this question in particular is a little confusing. I'll tell you honestly why. The reason for this is because of the diagram given. I'll read out the question, pay attention, try to prove me wrong again. Try. The question is, current is flowing in clockwise direction in a circular coil lying in a plane of a table. Alright, lying in the plane of a table. There's a table placed. On top of the table, there's a circular coil kept on which the current is flowing in the clockwise direction. Using the right hand thumb rule, state the direction of the magnetic field both inside the coil as well as outside the coil. Goda. Let's go. Sure, pakka, super easy. Let's see how many figures can get this right. If it is so easy, let's see how many figures can get this right. So much confidence. Inside south, outside north. Oh, into the page and out of the page respectively. All right. Any other answers? Any other interesting answers that I can find on the chat box? Out of the table, inside, outside north, inside south, outside north. Any other answer? Any other answer that you can think of? Done. That's it. No other answers. Okay, wait. Okay, my internet keeps getting disconnected. Just give me a second, guys. Unfortunately, my phone internet keeps getting disconnected. 1 second. Let me just connect to a different Wi-Fi. I'm not able to see your chats. So okay. Into the page. Side is South Pole. Outside is North Pole. right, white color annotator. All right, okay, white color. You guys would be able to see better in white. Okay, okay. There's no white, unfortunately. There's no. Is there white? Wait. Okay, there is white. Okay, you can see it. No, better. All right. Okay. Now to answer this question, guys. To answer this question. See, first of all, draw the circular loop. Current is going in clockwise direction. So this is the direction of current right now. This is the direction of current. If that is the case, if you were to use the Maxwell's right and thumb rule, which states that if current is flowing in a circuit, in a straight current carrying conductor, the thumb shows the direction of current and the enveloping finger shows the direction of the magnetic field. Now, if you pay attention, if I were to take this particular point, if I were to take this point, current is going in this direction. So you can, what I'm trying to show is this, people, that this circular loop can be drawn like this. It still resembles a circle. It still resembles a circle. So you're assuming that a circular coil is made from several straight current carrying conductor. That is what you need to understand. That is what you need to remember. A circular loop is nothing but several straight current carrying conductor placed in a particular manner, in a proper manner. If that is the case, then again, current is going in this direction right now. So current is going in this direction. So here, if you use Maxwell's right and thumb rule, you see that current on the inside is going in the downward direction. On the inside, it's going in the downward direction. On the outside, current is going in the upward direction. Simple. All you need to remember is this. On the inside, again, current is going in the downward direction. On the outside, current is going in the upward direction. Got it? Or you can remember, you can write it as how you can say it as south and north. You can say it like that also. South on the inside and north on the outside, because it's going like this. Again, please look at this one, guys. Maxwell's right and thumb rule. Try to do it yourself. Take your pen, hold your right hand such a way that the thumb shows the direction of current, which is pointing towards me right now. So if you look at the enveloping fingers, inside it is going like this, outside it is coming out like that, and hence on the inside it's going downwards and the outside it's going upwards. Got it? That's all done. Clear? 100%. Shall we go on to the next? Is it clear? Is everyone clear with this question? Because these kind of question for sure you're going to get. Maybe not the exact same one, but for sure you will have at least one question from any of the hand rules. It could be right and thumb rule, it could be Fleming's left hand rule or right hand rule, but damn sure you're going to have at least one question. So make sure you practice this. Please don't ignore it. For sure you will have one question. Pakka, I'm telling you. Either they might ask you as the working of a motor, where you have to use Fleming's left hand rule, or they might ask you about electromagnetic induction, or directly they can give you questions like this. But for sure you'll have questions. Make sure you practice. All right, understood? Shall we go on to the next one? All right, once again, Asumbul, just listen carefully. See, this is the conductor I'm taking. It's placed on a plane. It's placed, so imagine this is the surface, all right? Imagine this is a table. So the conductor is placed on the table. The circular loop is placed on the table. So here, if you look at this particular point, you see that current is coming towards me. Current is flowing towards you. So that means if you use Maxwell's right and thumb rule, the thumb is pointing towards you and the enveloping fingers are going in this direction and basically in anti-clockwise direction. So you can see that if you check over here, it's going to be like this. Current is going in anti-clockwise direction. So on the inside, it's going downwards, and on the outside, it is going upwards. Simple as that. All right. Now, I'm going to go to the next question, people. The 7th question, CBSE 2014 board exam. The question is, define 1 volt. Express 1 volt in terms of its SI unit of work and charge. With respect to work and charge, how would you express 1 volt, and also write the SI unit? Calculate the amount of energy consumed in carrying a charge of 1 coulomb through a battery of 3 volt. Fantastic question. 2 marks. That's all. This question carries 2 marks. So please remember, you don't have to write the entire Ramayana, Mahabharata, took Sita to Vanvas and all that. You don't have to write that. It's a 2 mark question. So keep it crisp, to the point. That is more than enough, because there are 3 different parts to this question. So if you just stick to the script, stick to what you're supposed to write, and don't beat around the bush, that itself will give you that 2 marks. So go ahead and write this, guys. Define 1 volt. Come on, first start with 1 volt. What is 1 volt? 1 volt can be defined as 1 joule of work to move a unit charge. Are Kushagra ji, awesome. Defined as 1 joule of work to move a unit charge. 1 volt is work done of 1 joule to move a charge of 1 coulomb. Fantastic, guys. Amazing. Silly question, sir. How do we get to know which log to use? That you need to, again, practice that. Practice is the only thing that can help you understand which rule to use when. But to answer this question, what is 1 volt? 1 volt is the potential difference. I'll write it down very cleanly over here. Potential difference is said to be 1 volt when 1 joule of work is done. When 1 joule of work is done to move a charge of 1 coulomb from infinity to a point. This is the right exact definition. I'll repeat it one more time. Potential difference is said to be 1 volt when 1 joule of work is done to move a unit charge or of 1 coulomb of charge from one point to another, or from infinity to a point. That is what is said to be 1 volt. You can say, instead of from infinity, you can say from one point to another. That is also right. So instead of saying infinity, you can say from one point to another, from one point to another, from one point to another. This is what is called as 1 volt. All right. Now, to talk about the SI unit, people, one potential difference, that is 1 volt, is basically volt is equal to work done by charge. This is the SI. This is the formula to calculate volt, and the SI unit is basically 1 joule is the work done is nothing but joules. So charge is nothing but coulomb. So joules per coulomb is the SI unit of work done, which is also written as volts. That's it. All right. Now to calculate the last part of the question, guys, very simple numerical. You need to find out what is the energy consumed. You need to find out what is the work done. Basically, the energy consumed in carrying a charge of 1 coulomb through a battery of 3 volts. Substitute the values. V is equal to W by Q. So here V is given as 3 volt. Work done is what you're supposed to find out. Charge is given as 1 coulomb. So take that to the other side. So W is equal to 3 into 1, which is equal to 3 joules. That's it. All right. Fantastic. But again, guys, I'll tell you this thing, very, very important. Look at the answers. Look at the marks given to a question. This is a 2 mark question, so you don't need to put a lot of work, a lot of time into it. There's no need for it. All right, please keep it short, keep it simple, because you need to spend a lot of time on the 4 markers and 3 markers. So keep that in your mind while you're writing the answers. All right, in your examination, please look at the weightage of the question and then answer accordingly. All right, guys, 8th question, 2009 board exam question. The question is, a piece of wire of resistance 20 ohm is drawn out so that its length is increased to twice its original length. Calculate the resistance of the wire in this new situation. Fabulous question. Fantastic question. Has been repeated several times in pretty much, I'm pretty sure a lot of you guys had this similar type of question in your pre-boards also. It's a very common question, a very important one. So go ahead, put it on the chat box, guys. What do you think would be the answer for this one? Come on. My God, guys. Fabulous. Awesome. It will be constant, okay? It will be constant. See, guys, this is what you need to understand. This type of question, where majority go wrong, is the fact that you have a wire whose resistance is given as 20 ohms. Now, initially, this wire is of length L and the area is also of A. Now what they're saying is that you're increasing the length to twice the length. Alright, so the new length, which I'll take it as L dash, is twice the original length. Now, if the same wire has been pulled to increase the length to twice its original length, will the area change or will it remain the same? This is what I want to understand. Will the cross-sectional area of this wire, will it remain the same or will it change? This is what I need you guys to tell me in the chat box. Will it increase, will it decrease, will it remain exactly the same? Exactly, guys, that is what you need to understand, because volume is remaining exactly the same even when you're increasing the length. Volume is what? It's nothing but the amount of matter content. Now, when you increase the length of this wire, you are not adding more atoms to it. You are not removing any atoms to it. All you're doing is changing the shape. So if that is the case, we know that volume is nothing but area into length. So the area, that is the old volume, is equal to new volume. So the new area into the new length, that is also exact, it's the same volume. So if that is the case, we can write as A into L is equal to A dash into 2L, because L dash is 2L, twice the length. So the area, new area, is going to be what? LL gets cancelled. So new area, A dash, is going to be A by 2. Once you do this, everything else becomes easy. All you need to understand is this one simple fact, that the area also decreases to half when you're increasing the length. Once you do that, everything else is exactly the same. Substitute the values, get the answer. So to calculate the new resistance in this case, so it's going to be what? R dash is equal to rho into L dash by A dash. Sorry, A dash, it's not A square, my bad people. So it's going to be A dash. Substitute the values over here. As simple as that. So R dash is equal to rho into 2L divided by A by 2. So this will go to the numerator. So it's going to be R dash is equal to 4 into rho into L by A. Now what is this rho into L by A? That is nothing but this, because R is what? R is equal to rho into L by A. That's it. So that is nothing but 20. So this whole thing is nothing but 20. This whole thing that you see over here is nothing but 20, people. This is nothing but 20 ohms. Substitute the value. So R dash is equal to 4 into 20, which is going to be equal to 80 ohms. That's it. That's all. 4 times the original value. Alright, 9th question, guys. Let's go on to the next question. This particular question was repeated twice back to back in 2010 and 2011. The question is, a coil made up of insulated copper wire is connected to a galvanometer. What will happen to the deflection of the galvanometer if this coil is moved towards a stationary bar magnet and then moved away, and name the phenomena involved in this? I'll repeat the question one more time. A coil made of insulated copper wire is connected to a galvanometer. What will happen to the deflection of the galvanometer if the coil is moved towards a stationary bar magnet and then moved away? Give reason to your answer and name the phenomena involved. Fabulous question. Go ahead and answer this, guys. Momentary deflection, pakka, 100%. Yeah. Electromagnetic induction. Galvanometer deflects to the right side. Okay, how? Okay, right side. Okay, you are assuming that it's going towards the right. All right. Momentary deflection first on one side. Exactly, Nupun. That is what you have to write. That is how you're supposed to answer this question as well. See, people, there is 2 parts to this. There is 2 parts to this. Initially, when the coil is moved towards the magnet, it is when it's moved towards the magnet, there is going to be a momentary deflection. Absolutely, deflection to one side. You have to mention that. You can take it as left side or right side, but it is moving to one particular side. Again, when you're moving the coil away this time, when you're moving the coil away, this time once again you're going to have a momentary deflection. But this time the deflection will be towards the opposite side. You have to mention that. That is also important. It's a 2-mark question, but you need to answer that also. There's going to be a momentary deflection, but this time the deflection will be in the opposite direction. Okay, now that you've answered that, go on to the next one. what is the reason for this? Why does this happen? There's three important parts. It's a 2-mark question, but there are 3 different sub questions given. Why does this happen? What is the reason for this? Exactly, your science lab. Absolutely, exactly, Delcy. There is a voltage induced or a current induced because of the relative movement or the relative motion between the coil and the magnet. Because of the relative motion, there is some sort of motion, relative motion. When there is a change in the magnetic field or when there's a moving magnetic field, there is a current induced in a conductor. That is what is called as electromagnetic induction. And lastly, what is the phenomena involved? EMI, that's it, electromagnetic induction. Simple. Alright, it's a 2-mark question, but there are 3 different parts to it. Do not miss out anything. See guys, all I'm trying to say is this: do not give any opportunity for your invigilator to deduct even 1 mark. Even 1 mark also, forget about 1 mark, even half a mark also, you should not give them an opportunity to do so. Alright, no matter what, do not let them deduct any marks, whatever it is. You should make sure that you're covering all your bases, whether it's 1-mark question or 2-mark question, or if it's 3-mark question, do not give them an opportunity to cut your marks. All right, they're waiting for that. All right, they're waiting for that. You give them an opportunity, they will do it. They will do it because they'll be stringent. They don't know who you are, so they will deduct it. So make sure you don't give them an opportunity to do that. All right. Okay, guys, the last 2-mark question. Sorry, the examiner. My bad. Invigilator is what I'm. All right, my bad. Examiner, corrected. All right. Last 2-mark question. This is the last 2-mark question, guys. After which we'll move on to the 3-mark question. 2008 CBSE board exam paper. The question is: state the relation between work, charge, and potential difference for an electric circuit. Calculate the potential difference between the 2 terminals of a battery if 100 joules of work is required to transfer 20 coulombs of charge from one terminal of a battery to another. CBSE 2008 board exam. Such an easy question. In fact, guys, we have just done this question couple of minutes ago. We have done the exact same question. So put it down in the chat box right now. Fabulous, guys. Fabulous. Super awesome. Super awesome. Absolutely wonderful. First of all, tell me, guys, what is the relationship between work, charge, and potential difference? What is the exactly, guys? Fabulous. So the answer for this question, first part is that the relationship between work, charge, and potential difference is that potential difference is nothing but the work done to move a unit charge from one point to another. That is what is potential difference. So this is the relationship between work, charge, and potential difference, where V is the potential difference, W is the work done, and Q is nothing but the charge. Alright, that is the first part. Now to calculate the answer for the second question, what is given over here? The given data is work done is given as 100 joules. Fabulous. The charge given is 20 coulomb. All you have to do is find out the potential difference. So potential difference is equal to what? 100 divided by 20. So 2 5s are 10. So this is going to be 5 volt. That's it. All right. Fabulous, guys. Fabulous. Give a big round of applause to yourself now, because you have done 10 questions of 2 markers. How many of you guys have gotten all the 2 mark questions right until now? All 2 mark questions correct. All 10 questions you guys got all of them correct. Like no wrong answers at all. No wrong answers at all. Done. Very awesome. So what happens to the current produced when bar magnet is moved towards the circuit? There's going to be current induced. That amount of current induced will depend on several factors, like how fast you're moving the magnet. That is one thing. How strong is the magnet? That is also one more thing. And how many number of turns are there? All of these are deciding factors in deciding how much current is induced. All right. So those are deciding factors. Fabulous, guys. Fabulous. Give a big round of applause to yourself. Awesome job, guys. Awesome job. Keep it up. Keep up the good job. Don't, again, you need to be confident, but don't be overconfident. So with that said, let's go on to the 3 mark questions right now. Solve some of those questions as well. And then we'll go on to the 4 mark questions. All right. Get ready, people. All ready? Give me a oh yeah, people. How's the Josh? Give me a oh yeah. How's the Josh? All good. So for galvanometer, can we mention left or right? You can, no? You can mention, initially it's going towards the right and then it's going towards the left, or you can just say initially it's going in one direction and then it's deflecting in the opposite direction. That is also perfectly fine. Yeah, that's the spirit. That is the spirit. All right, now let's go to the 3-mark question. Here's the first one. 11th question of today. Here's a question. A coil of insulated wire is connected to a galvanometer. What would be seen if a bar magnet, when its south pole towards one faces the coil, of a south pole of a magnet is facing towards the coil? What will happen if you move it quickly towards it? Second sub question, when you quickly move it away from it. Third question, when you place it near one face. And lastly, name the phenomena involved. The same question that we just did, the exact same question. The only difference is that this question was asked in 2010 board exam. The previous one was asked in 2009 board exam. This was asked for 3 mark. That was asked for 2 mark. Same question. Easy question. Exactly, people, exactly. When you move it quickly, there is going to be a deflection in the galvanometer. The deflection will also be, you can say that there's going to be a larger deflection, larger momentary deflection. Why? Because you are moving it quickly. The relative motion of the magnet also matters. What I'm trying to say is, if you move the magnet quickly, then there'll be a greater deflection. There will be a greater deflection because of the faster movement as well. So there's going to be a deflection, a momentary deflection of the galvanometer when you move it quickly towards it. Again, when you move it away, there's going to be again a deflection, but this time the deflection will be in the opposite direction. Thirdly, what happens when you place it near its face? What is going to happen? When you keep it at one point near its face, what's going to happen? Quickly now, what will happen? If you keep it at one place, current is going to be induced, no? Again, there's going to be deflection left, right, center, no? Opposite direction, no, Sneha? Exactly. Opposite, no? Hurry, electromagnetic. What will happen if you place the magnet near? Exactly. There will be no deflection. There will be no deflection whatsoever. Because why? Because there is no movement between the magnet and the coil. And when there's no movement between the magnet and the coil, there will be no potential difference induced. There will be no current induced, and hence no deflection. Alright, for the last one, people, the last sub question, name the phenomena involved. Damn easy. Electromagnetic induction or EMI. Faraday's law of electromagnetic induction, or EMI, all of these mean the exact same thing. But please write electromagnetic induction and then in brackets, you can write it as EMI. Alright, that's all. Easy question, no? Vacha level question. Alright, people, 12th question. Finally, we have a circuit with us. 12th question asked in 2008 CBSE board exam. The question is, for the circuit shown in the diagram given below, calculate A, the value of current through each resistor, the total current in the circuit, the total effective resistance of the circuit. Let's start with the first one. What is the value of current through each of these resistors? Put it on the chat box, guys. 2 amperes? 2 amperes. The total current, okay, I'm not talking about the total current. Let's start with the first one, the value of current through each resistor. I'll do it. I don't have a problem. I'll do it. In your exam also, I'll come and sit and write your exam. No. In your exam also, I'll just call me. Give me a call. No, I'll come and solve this also. In your exam also, I'll sit and solve. For the first one, let's start with the first one. It's a 5 ohm resistor. The potential difference connected, the potential difference of the battery is 6 volts. What is the value of current flowing to the first one? Let's go, guys. Let's go. Quickly. I'll just keep my phone on this side so that I can see the chat clearly. 6 by 5, pakka? Absolutely, guys. Now for the first one, I don't have much space here, so I'll just, I'm going to shorten this thing. I'll just keep my video to the side for a second, guys, so that I'll have enough time to work this. But again, you can download the notes later, so don't worry about this one. Okay, so for the first one, guys, let's start with the first one. It's a 5 ohm resistor, right? Now, we know that according to Ohm's law, we know that current is equal to voltage by resistance. Now, since they are all connected in parallel, their potential difference will be exactly the same. Through the 5 ohm resistor also, the potential difference would be 6 volts. Through the 6 ohm resistor also, the potential difference will be 6 volt. Through the 30 ohm resistor also, the potential difference will be 6 volt itself. Now, if that is the case, Potential difference is 6 volt. Resistance is 5. So it's going to be 6 by 5. If you want to convert it to decimal points, 5, 1. So it's going to be 1.2 ohms. Sorry, 1.2 ampere. My bad. 1.2 ampere. This is the first one. Now for the second one. For the 10 ohm resistor, again the same thing. Potential difference is 6. Resistance is 10. So it's going to be 0.6 ampere. Simple. For the third one, the 30 ohm resistor, it's going to be what? It's going to be, the current is going to be 6 by 30, which is nothing but 6 5s are 30. So it's going to be 0.2 ampere. So now this is the first part of the question. The value of current through each resistor. All of this will give you 1 mark. It's a 3-mark question. All of this will give you 1 mark. That's all. Now for the second one, what is the total current flowing through the circuit? What is the total current? What is the total current? Quickly. What is the total current? Simple. Easy. Exactly. Oh, हमरा हिंदी तो next level है. Exactly. Exactly. Total current will be, I'll take it as I5, I10 and I30 to avoid confusion. So total current would be basically the combination of all the three, which is going to be equal to I is equal to what? I5 plus I10, that is resistor, current flowing through resistor, 5 ohm resistor, current flowing through the 10 ohm resistor, and the current flowing through the 30 ohm resistor, which is equal to what? 1.2 plus 0.6 plus 0.2, which gives you a value of 2 amperes. That's it. Now for the last one, people, what is the effective resistance? You have to calculate it. That is damn easy. So all you do is this: 1 by R equivalent is equal to what? 1 by R5 plus 1 by R10 plus 1 by R30, which is basically equal to what? 1 by 5 plus 1 by 10 plus 1 by 30. Now find out the LCM. I believe 30 is the LCM. So 10 into 3, 3, 5, 6 are. So 6 plus 3 plus 1 divided by 30, which is equal to what? 10 by 30. This is 1 by R equivalent. So R equivalent is equal to 30 by 10, which is equal to what? 3 ohms. That's all. That's all. Fantastic. Fantastic job, you. Fantastic. So that, my friends, is the 12th question for today. Fabulous job, guys. Fabulous job. So proud of you guys. You guys are doing a fabulous job. And I mean it because, any question I've asked, I've never seen anyone going with the wrong answer. I can see that the majority of the class is giving the right answer itself. So fabulous. So for effective resistance, can we directly do V by I? You can. Again, you can absolutely do it that way also. But again, you need to, you can actually. In fact, in this scenario, you can. Why? Because you know the value of current also. But in most cases, we don't generally find out the total current flowing through the circuit. In most cases, we don't. In this scenario, you can. In this scenario, you can directly say it as R is equal to V by I total. So you can directly do it this way also, absolutely fine. But in most cases, we don't find out the total current flowing through the circuit, especially in parallel connection, we don't do that. So, stick to the things that you already know of. So that's what I would say. All right. Okay, anyways, let's go on to the next question, people. 13th question, CBSE 2009 board exam. This particular question was asked. Again, a fabulous question. So pay attention, read the question carefully, and then answer. The question is, two resistors with resistance 5 ohms and 10 ohms respectively are to be connected to a battery of EMF 6 volt. So as to obtain the minimum current flowing, the maximum current flowing, you also have to find out how will you connect these resistance in each of these cases. If you want minimum current and if you want maximum current, how would you connect these resistors? Secondly, calculate the total strength of current in both the cases. Calculate the strength of the total current in both the scenario. An absolutely fabulous question, which I'm pretty sure a lot of you guys will go wrong in. Are you sure? Are you sure, Ashwath? Are you sure? Are you sure, Jay? I knew a lot of you guys would go wrong in this. I knew it. I was 100% sure that a lot of you guys will go wrong in this particular question just because they've asked the minimum and maximum current. Listen carefully, guys. Listen carefully. I'll tell you how to answer this. It's actually quite simple. For the first one, sorry for that. See, guys. If you want minimum current to flow, let's start with the first one. If you want minimum current to flow, would you connect them in series connection or would you connect them in parallel? Would you connect them in series or would you connect them in parallel? Series or parallel? Series, pakka. You have to connect them in parallel, people, not series. Not series. Budbako. As Abhishek sir says, Budbako. Not series. Parallel. See, in series connection, current will remain same. Current will remain same. But please remember, guys, if you have two resistors connected in series, 5 ohms and 10 ohms, the potential difference will not be the same. And according to Ohm's law, we know that V is directly proportional to I. Okay, I'll just explain this because there are a lot of people who have this question. So let me just explain this. There are two resistors, 5 ohms and 10 ohms connected. Alright, back to back. Now, tell me one thing, people. Will the potential difference across the 5 ohm resistor and the 10 ohm resistor would be the same? Would it be the same? Would the potential difference across the 5 ohm resistor and the 10 ohm resistor, would it be the same in series connection? Series connection, same? No, it will not. Across a 10 ohm resistor, the voltage will be a little lesser. It will be lesser. So if that is the case, then current flowing through it also will not be that high. See, current flowing through both the 5 ohm and 10 ohm resistor is constant. It is constant. But it is not high. It is going to be on the lower end of it because the resistance in series connection is high. We know that in series connection, the equivalent resistance will be much more higher. And according to Ohm's law, we know that I is inversely proportional to R. In series connection, the resistance is high, so current will always be less. Alright, so you have to connect them in parallel if you want in minimum connection, my bad. If you want minimum, you would connect them in parallel. Array, what did I just say? So if you want, I was explaining for maximum and I wrote it as minimum. Sorry. If you want minimum current, you will connect them in series. If you want maximum current, you would connect them in parallel. Alright, if you want maximum current, you will connect them in parallel. My bad. Alright, I told us maximum and I wrote as minimum. I was explaining for maximum all this while and I wrote as minimum. My bad. First one is minimum. So if you want minimum current, you would connect them in series. If you want maximum current, you would connect them in parallel. Alright, my bad, people. I'll just clear the confusion one more time. If you want minimum current, you will connect them in series. Why? Because the current value would be the same, but then the resistance is high in series connection. Since the resistance is high, the current flowing through them would be less. Alright, exactly, na? I was explaining for minimum all this while, and then I wrote, maximum all this while, and I wrote it as minimum. My bad. I read the first one as maximum. My bad. Alright. If you have maximum current, on the other hand, you would connect them in parallel. Why? Because in parallel connection, the resistance is going to be less. The resistance in parallel connection will be lesser, and hence the current would be maximum. All right. Now to calculate the how do you connect? Yeah, that's done. Calculate the strength of current. Now to calculate the current, it's very simple, people. So in the first one, the equivalent resistance what for the first one in minimum connection when you connect them in series, the equivalent resistance is what? R equivalent is equal to what? 5 plus 10, which is equal to 15 ohms. So what will be the current flowing through it? We know that current is equal to V by R equivalent. So this is going to be what? Potential difference is 6. They both connected to the 6 volt battery divided by 15. That will be the answer. So 6 by 15 would be the value for it. You can calculate and convert it to decimal points if you want to. So this is for the current flowing through, the current in the the series connection. Now in parallel connection, you'll have to do it individually. You have to find out the current flowing through the 5 ohm resistor and the 10 ohm resistor, then add it up just like what we did before. So in parallel connection, again guys, I'm not able to write it, so I'm just gonna reduce my screen size and then write it on this side. So in parallel connection, on the other hand, RP, one second guys, let me just turn on the fan there, it gets very hot here. Alright, so in parallel connection, on the other hand, you have to find out the current, the total current is what you're supposed to find out. So here you have to find out the individual current flowing through it. So RP, find out the equivalent resistance, or let's find out the equivalent resistance and find out the total current directly. So 1 by RP is equal to 1 by R1 plus 1 by R2, which is equal to 1 by 5 plus 1 by 10. So equivalent resistance is what? Into 10, into 2, into 2. So 2 plus 1 divided by 3, which is equal to 3 by 10 would be the equivalent resistance. This is 1 by Rp. So Rp is equal to 10 by 3. Now to find out the current, I is equal to V by R again. The potential difference would be exactly the same. So it's going to be 6 by 10 by 3. 3 will go to the numerator. So it's going to be 6, 3, 18. So 18 by 10, which is going to be 1.8. All right. So this is going to be 1.8 ampere. So current flowing through the parallel connection is 1.8 amperes. And the current flowing through the series connection would be how much? It is how much, people? 6 by 15 is how much in the chat box? 0.3. No, it will be around 0.3, 0.4 is what you're gonna get. All right, that'll be the answer. All right, guys, let's go ahead. Let's speed up the process a little. We have done 14 questions. This is the 14th question, so let's quickly finish off at least till in the next 10 to 15 minutes. Let's try to do at least 20 questions, and then we'll also call in Bhawna Mam as well to do the last couple of questions. All right, 14th question. In the diagram, we are looking down on the setup. All right, the current is flowing in the clockwise direction. Which way does the coil rotate is the question. Go ahead and answer this one, guys. In the diagram given, the current is going in clockwise direction. In which way will the coil rotate is the question. You can see the polarities of the magnet as well. You can see the direction of current. All you have to do is find out the direction in which it's going to rotate. Whether it's going to rotate in clockwise or anti-clockwise is what you're supposed to find out. Now, just to make it easier, I'm going to name this coil as ABCD just for the sake of it. Now, you guys tell me in what direction will this coil rotate. Pakka, 100%. Okay, let's start with the first one, people. Okay, so sorry. Forgot for a second that my video is still there. Okay, now for the first one. If you look at AB, in what direction will AB move? Will it move upwards or downwards? Let's start with that one. If you look at AB, will it move in upward direction or downward direction? Let's go. Pakka? Anti-clockwise? Exactly. Awesome. Niche, no? Exactly. So how do you do this? Fleming's left-hand rule. Very simple. So according to Fleming's left-hand rule, your thumb shows the direction of force, index finger shows the direction of magnetic field, and your middle finger shows the direction of current. Now here, the magnetic field is going from your left to your right, which is shown by your index finger. All right, just to keep it even more clear so that you focus. So here you can see that the current is going in, the magnetic field is going from left to right. All right, from your left to your right. This is the direction of magnetic field. Current is going in this direction. It's going in the upward direction, all right? It's going from south to north. This is the direction of current. So what is the direction of the force on AB? AB in this case will go in the downward direction. BC on the other hand will not have any deflection. There'll be no deflection. Why? Because people, BC, the magnetic field and current both are parallel to each other. In that case, there'll be zero force acting on it. So there'll be no deflection on BC. Whereas CD on the other hand, again, current is going in the downward direction. Magnetic field is still going from left to right. Current is going in the downward direction. So if you look at the direction of the force on CD, CD would be in the upward direction. In other words, it's going to rotate in anti-clockwise direction. Now again, why am I writing so much, people? Because this is a 3-mark question. Got it? It's a 3-mark. You can't just say, sir, anti-clockwise. You can't just say it is anti-clockwise. All right. You can't just write it and expect 3-mark. It's a 3-mark question. So you need to write in detail. You have to explain a little. You have to say that in AB is going downwards. BC and AB will have no deflection. Both BC and AD will have no deflection, and CD will go in the upward. It's a 3-mark question, da. You can't simply write anti-clockwise and say, oh, why am I not getting marks? You can't do that. All right. It's a 3-mark question. You have to be detailed. You have to explain. Only then you'll get those 3 marks. Got it? Sure. Da. We'll take a small break. All right. It's a 3-mark question. So you can't see. This is what I'm trying to tell you. You can't just say this. You can't just say this for 3-mark. You need to explain a little at least. A little bit of explanation is definitely needed. All right. Okay, guys. 15th question. All right. Now, do you guys want to take a small break? Or do you guys want to continue? All right. Do you guys want to take a small break? A tiny little break? Or do you guys want to continue? What do you say? Break? Tiny break? Or do you want to continue? I'm okay with anything. Shall we call Bhawna Mam then? Shall we call Bhawna Mam? Yeah? Break, huh? Shall we call Bhawna Mam for the break? Continue. 5 minutes. Continue. Continue. All right, we'll continue. We'll call Bhavna Mam also in the while. All right. So Bhavna Mam, please join if you're watching this session. Please join in the meantime. Just give me 1 second, guys. I'll call Bhavna Mam also so that she can also, bring in and bring a new perspective to life. Bring a new perspective life. 1 second. 1 second. Let me just see where. Okay, 1 sec, guys. 1 sec. Don't worry, guys. Again, I'll make sure that all the notes are uploaded in the next 30 minutes max. I'll make sure that all the notes are uploaded. In the meantime, I'll also call Bhavna Didi, Bhavna Auntie to the stage so that, she can also add some perspective to life. Again, she those next level. Bhavna Mam's answers are next level. Telling, 5-mark question, you'll get 10 marks. 5-mark question, you'll get 10 marks. All right, that's how our answers would be. All right, anyways, so people, we will in the meantime until Bhavna Mam joins, let's go back to the question. We'll solve this in the meantime. Okay, so yes, all right, let's let Bhavna Mam join. In the meantime, guys, let's go ahead and do this one now. All right, let's go ahead and do this one. All right, 15th question, people. Name and state the rule used to determine the direction of magnetic field produced around a straight current carrying conductor. Okay, Bhavna Mam is here. Is Bhavna Mam there? Where is Bhavna Mam? Now, 1 sec. She just asked me permission to admit her. Where is Bhavna Mam? Wait, people, wait. All right, 1 second. Now, 1 second. I'm trying to figure this out. Just give me 1 second. Why is Bhavna Mam not joining? Wait. All right. All right, just give us 1 second. Unfortunately, Bhavna Mam is not able to join. Give me 1 second. Once it's done, we'll continue. We'll continue. In the meantime, put on the answer for this question. Right and thumb rule. Explain right and thumb rule also. In the meantime. Put it down in the chat box. Give me 1 second, people. I'm trying to figure this out. Wait. Where is the waiting room? Where is the participants? Yes. Bhavna Mam ji. Yes. What's up? 1 second, guys. 1 second. I'll just, reduce the size of this. Yes. No, wait. Immersive. No, wait. Full screen. Wait. This is kind of hard. Just give me 1 second, people. Just give me 1 second. Gallery view. This is better, no? Yes. Ma'am, can you hear us? Can you see us? Guys, in the meantime, we'll continue. Don't worry. We'll continue. All right. We are just trying to figure out how to, I am trying to figure out how to, yes, screen share. No, I'm supposed to screen share. Yes. All right. Okay, people. Unfortunately, I think Bhavna Mam is having some sort of tech issues, but we'll wait for her to join. In the meantime, we'll continue, people. All right, so here's the 15th question. All right, 15th question is very simple, people. Exactly correct. You have to use basically Maxwell's right and thumb rule over here. According to Maxwell's right and thumb rule, it states that if you hold a straight current carrying conductor such a way that the thumb shows the direction of current and all the enveloping finger shows the direction of magnetic field. Again, it's a 3-mark question, so please state it. It and please give a detailed explanation for all of this. All right, I think Bhavna Mam is having some sort of tech issue, or is it me who's having the tech issues? I'm not really sure. Lag. All right, okay, 1 sec, guys, 1 sec. I think there is some sort of issues. Lag, too much lag. 1 sec. Key ho gaya. 1 second. All right, for now I'll just 1 sec. I'll just leave the meeting for now. Guys, is it better now? 1 sec. Is it better now? Can you guys all hear me now? Buffering. Jai Shri Ram. Can you guys hear me now? Now is it better? 1 sec, people. 1 sec. Let me just check. All good. Now is it better? Now all good? Blurred. Right? Laggy. 1 sec. I don't know what is happening. Lag. Too much lag. Arey. Okay, 1 sec, people. 1 sec. Trying to figure it out. Better now? Is it better now? Now, can you guys all hear me? Now is it fine? Still buffering. Stuck. Extreme lag. 1 sec. Let me see what is the issue. 1 sec. Arey. Cha. Yeah, don't worry. Okay. 1 sec, people. 1 sec. Let me just see what the issue is. Give me 1 second. I'll just check my internet speed. I don't know what is the problem. This happens all the time. When I'm in good flow, no, that is when all of this happens. Alright. Okay, internet speed is good. And why? Why all this? Why lag? Now is it better? Now, okay, no? Alright. Okay. So moving on. Bhawna Mam, please, send me the link later. Alright, 16th question. Let's go on to the 16th question. We've already spent a lot of time. Let's go on to the 16th question. I hope it's better now. 16th question is this. Define what is electrical power. Express it in the terms of potential difference and resistance. And B is, an electrical fuse is rated at 2 amperes. What is meant by this statement? C is, an electric iron of 1 kilowatt is operated at 220 volt. Find which of the following fuses can be used if it's, respectively, that is a 1 ohm resistor, 1 ohm, 3 ohm and 5 ohm fuse can be used in this particular scenario. Let's start with the first one. What is electric power? How would you define electric power? Let's start with the first one. Ultra mega lagger. They again lag what? Again laggy. Again still lag. Array. Alright, ultra supreme lag. My god, a buffer. Why is this happening now? Why is this happening? Wait, one sec. Just give me a second, guys. Just give me a second. I'll try to figure it out. Why is this happening? One sec. Let me look at my internet speed. Just give me 1 second. Ultra lag, supreme lag, mega, ultra pro, max lag. Okay, mouth still. Just give me 1 second, people. Let me just look at my upload speed as well. Just give me 1 second. Array, why is there a lag now? My internet speed is so good. I'm getting 300 Mbps, more than what I paid for. Still there's a lag. Okay, now is it fine? 1 sec, guys. 1 sec. I don't know why this is happening. Just give me a second. I don't know why. Why is there a lag? Now is it fine? Now it's okay? Okay, 1 sec, guys. 1 sec. Legendary lag it since. Alright, now it's fine. No, it's fine. No. I know exactly, Vandana. Hamra luck to bahut hi kharab hai. Sir, you better turn off your video. Okay, I'll see if that works. Let's just give it a shot. Is it better now? I'll just make it smaller. Now is it better? I don't know why this is happening. Oh my god. Like such bad luck. I don't know why. I think it's all because of Bhawna Mam. All because of blame Bhawna Mam for it. After I bought her in, that's when all this started. She cursed us. So it's all because of Bhawna Mam. Bhawna, auntie ji, ki kar rahe ho aisa? Kyun aisa kar rahe ho? Now it's fine, no? Now it's fine, no? Alright, okay, let's go on. Alright, so first one, guys. Define what is electric power. Express it in terms of potential difference and resistance. So what is electric power? In simple words, guys, power is nothing but the rate of doing work, or the rate at which electrical energy is converted per unit time. That is what is power. Let me repeat it one more time. Electric power is nothing but the rate of doing work. You can explain it as rate of doing doing electrical work. You can say that, or you can say that it is nothing but the rate at which electrical energy is converted per unit time or is used per unit time. That is what is called as electrical power. Now, in terms of potential difference in resistance, if you have to explain it, if you have to mention it, how would you put it? In terms of formula with respect to potential difference in resistance, what or how would you denote power? Put it down in the chat box. Let's go, guys. Let's go. You can say that also. Rate at which heat is dissipated. Any of this. You can say it. That is nothing but work done. So you can say that rate at which electrical energy is dissipated or heat energy is dissipated. All of these would give you the exact same thing because it's all nothing but the definition of power. Exactly, guys. Please remember that potential power is nothing but potential difference into current. From Ohm's law, we can say that current is equal to what? V by R. So substitute that over here. What will you get? P is equal to V square by R. This is the formula to calculate power when potential difference and resistance is given. So this is how we calculate it. Okay, now for the second one, guys. An electric fuse is rated as 2 ampere. Now, what does this mean? If there is a fuse which they have told has a power rating or a current rating of 2 ampere, what do you mean by it? What does it really mean? What does that really mean? Come on, quickly, da. What does it mean? Chat box. Jaldi karo. Exactly, V square by R is the formula. That's what I've written down. I don't know if you guys can make out my handwriting. It's V square by R. Okay. Now for the second part of the question. What is the meaning of 2 ampere power rating, or if you have an electrical fuse which has a power rate or current rating of 2 ampere, what does it really mean? Exactly, Jyoti. Exactly. Absolutely fantastic. Absolutely fantastic. Super awesome. Exactly, guys. See, this 2 ampere, I'm going to reduce my screen size again. If 2 ampere is the current rating of a fuse, that means that the maximum current that can flow, is 2 amperes. If it is greater than that, if it is greater than 2 amperes, then that fuse is going to melt and disconnect the entire circuit. That is what it really means. Okay, for the last one, guys, which is again a very important one for C part of the question, there are 3 fuses given, 3 fuses with 3 different current rating. One is of 1 ampere, the other is of 3 amperes, and the other is 5 ampere. They have given the data that the power rating, the power of this is 1 kilowatt. They have connected this to a 220 voltage source. What fuse would be best suitable or can be used in this particular scenario is the question. Exactly. Absolutely discovery science. Absolutely. Welcome. All right. Okay, guys, quickly put it on the chat box. If you have a power rating of 1 kilowatt, right, and the potential difference is 220 volt, what fuse can you use in this scenario? Array, fantastic. Give a big round of applause to yourself, guys. Give a big round of applause to yourself, because honestly, guys, you guys are doing a fabulous job. Hands down, you guys doing a fabulous job. No doubt about it. Please keep it up. Again, don't be overconfident, but at the same time, don't be underconfident also, because all of you guys are doing a fabulous job, giving the right answer. I don't see any wrong answers in the chat box at all. Super amazing. Keep it up, people. Now, to answer this, again, very simple. All you have to do is find out the current. We know that P is equal to V into I. I is equal to P by V. Now here, guys, power is given as 1 kilowatt, so convert this to watts, so it's going to be 1000 watts. So it's going to be 1000 divided by 220, 0 gets cancelled, 2, 11, 2, 5, 10, so it's going to be 50 by 11. When you calculate this, you'll get us 4 point something, 4.5 something around that is what you're going to get. That means that you can use a 5 ampere, fuse or current rating of 5 ampere wala fuse in order to use this device in a safe manner. All right, so that's the answer. Let's go on to the next question, people. Again lag. All right, okay, let's go to the next question. So this is the answer, people. You'll find it all over here. All of the notes would be put up in the description, so you can download it later and go through it whenever you feel like. All right, let's go to the next question, people. 17th question. Let's go. 2 devices of rating 44 watts, 220 volt and 11 watts and 220 volts are connected in series. The combination is connected across a 440 volt main. The fuse of which of the 2 devices is likely to burn when the switch is turned on? A fabulous question. Honestly, fabulous question. Like this question, honestly speaking, guys, out of all these questions I've done so far, this is by far the most logical and by far the most amazing question out of all. Honestly, because I really like this question a lot. So read the question carefully, you'll understand this. 2 devices of rating 44 watt and 220 volt and 11 watt and 220 volt are connected in series. The combination of these 2 are connected across a 440 volt pin. The fuse of which of the 2 devices is likely to burn when you turn it on? Fabulous question. Try to do your best. I'll also do it parallelly, but I want you guys to do it as well. Amazing question. Again, please try your very best. Do not wait for me to answer it. I want you guys to give your best. So try your best. Put it on the chat box. What do you think is the answer for this one? All right, let's start with the first one. I'll tell you how to do this. I'll tell you how to approach this. First of all, write on the given data. What is given to you guys? First thing that is given is, people, that the power rating P1 is given as 44 watts. All right. V1 is given as 220 volts. P2 is given as 11 watts and V2 is given as 220 volt. But please remember, guys, both of them are connected in series. both of them are connected in series. So basically this is what two devices, you can just take it as a resistor just for the sake of it. It is easier to denote. So there are two resistors, you can say there are two resistors connected one after the other, right? This is what you have, right? Now here's the thing, guys, they are connected to a 440 volt main. You need to find out which of these would burn. If both of them are connected to two different fuses, which fuse of which device will burn faster is the question. Is it? Sure. Pakka. 11 watt. Pakka. Alright, now the thing is, guys, it's a 3-mark question, so you need to be a little bit more, you have to show the calculation as well. So let me show you how to do this. First thing first, people, find out the resistance of both of these. Alright, how do you find out the resistance? P1 is equal to V1 square divided by R1. Right? So how much is this? This is going to be equal to what? 44 is equal to 220 into 220 divided by R1. Which is what? Take P1 to the other side. So P1 is equal to 220 into 220 whole divided by 44. How much is that, people? Please put it on the chat box. 220 into 220 divided by 44 is how much? 220 into 220 is around 48400 divided by 44. This, when you simplify, you will get it as how much? You'll get it as something around 1100 ohms. If I'm not wrong, 1100 ohms is what you have. This is basically your resistance for the first device. Now do the same thing for the second device also. Do the exact same thing for the second device as well. So P2 is also equal to what? V2 square divided by R2, which is equal to what? 11, which is equal to 220 into 220 divided by R2, which is, keep it as it is. So R2 is what? R2 is equal to 220 divided by 220 into 11. Again, the same thing, 48400 divided by 11. This will give you how much? Put it on the chat box, people. How much will you get? Something around 4400, if I'm not wrong. 4400 ohms is what you get. Clear? Pakka? 100%. Now both of these is what? The value of resistance of the individual, of the individual devices. The resistance, the first one is 11,100 ohms, and the resistance of the second device is 4,400 ohms. Now, people, you need to calculate which device will burn faster. So in order to calculate that, what should you do? You need to basically calculate, first of all, because they are connected in series, find out the value for current. Why I'm telling you this, people, you have to use Joule's law of heating over here. All right, I'm gonna write it with white color so that you guys can clearly differentiate all the things that I'm writing. Again, people, please make sure that you download the notes later. So here, people, current, you see, H is equal to what? I square RT. All right, this is one formula to calculate the the heat energy produced. Since time is not given, we'll just assume it as 1 hour. All right, we'll just, because both of them are, you can say that they've not mentioned for how long it is used. We'll just take it as 1. All right, we'll just take it as 1. So you have the value for resistance. Time, you're going to take it as 1 hour. You have to find out the value for current here. Since both of them are connected in series, how will you find out the current? The resistance, this one is 4,000, this is 1,100, my bad. This is 1,100. This is 4,400. So calculate the value of current. Simple. What is current? Current is equal to what? V by R. R equivalent. It is connected across a 440 volt potential difference. So it's going to be 440 divided by what is the equivalent resistance? R equivalent is equal to what? 4,400 plus 1,100, which is equal to what? 5,500 ohms. So it's going to be 5,500 over here. Simple. What is the value of current? Put it on the chat box, quickly. Chat box. Yeah, you can do that. You can absolutely do that. I'm doing it in, I'm doing it step by step so that there's no confusion, because a lot of you guys go wrong in the mathematical calculation part of it. To avoid confusion is why I'm still showing you step by step. So initially what I did, I found out the resistance of the first one, I found out the resistance of the second one, found out the equivalent resistance, and now I'm finding out the value of current. Which is what, people? 4,440 divided by 5,500, which when you calculate is how much? Exactly. Thank you, Puneet. It's going to be around 0.08 ampere. This is the value of current. This is the value of current flowing through the circuit. If that is the case, can you find out the heat generated in both of them? Absolutely yes. So H1 is equal to I square is what? 0.08 the whole square into 1100 into 1. Time is, I'm just going to assume it as 1 hour. You can take it as 1 hour. So H2 is also equal to what? 0.08 the whole square into 5500 into 1. How much will you get, people? Exactly. Fabulous. So if that is the case, then what is the answer for the heat generated? People, put it on the chat box quickly. If you calculate, you will get this is something around 7.04 joules, if I'm not wrong. And this one, you will get it as how much? Maybe around 28, if I'm not wrong. 28, maybe 28 joules, something like that is what you're going to get. 28, we'll just take it as 28.0605, something like that, right? 05 joules is what you're going to get, which means that clearly the second device, the 11 watt 220 volt valve, is the one that is going to melt faster compared to the first one. Got it? Clear, people? Understood? I know it's a really long calculation. There's no denying it. I'll just turn off my camera for 1 second so that you can see the whole picture as one. This is what you're supposed to do for this particular question, people. You need to first initially find out what is the resistance, the individual resistances. Once you find out the individual resistances, find out the equivalent resistance. Once you find out the equivalent resistance, then find out the value of current, because they are both connected in series. Once you find out the current, then and only then can you find out the heat generated in both the circuit. So once you find out the heat generated, you can clearly see from here that the second one, that is the 11 watt device, would be the one that would actually melt faster. The fuse of the 11 watt device would melt faster compared to the 44 watt one. All right. Okay, people, let's go on to the 18th question once again. Before I go to the 18th question, once again, let's just see if if Bhawna Mam has joined or not. Let me just check if Bhawna Mam has joined or not. Just give me 1 second, people. In the meantime, let me know if you guys have understood everything, or if there's any sort of confusion. Please let me know that as well. 1 sec, people. Okay. I'll do one thing, guys. I'll just start another link. Just give me 1 second. All right. Finally. Bhavna ji, ki ho gaya? 1 second, Bhavna. All right. Finally. Guys, please welcome the very own auntie of the year, Bhavna Mam.
Very funny, like ha.
Obviously yes. One sec, guys. I'll just share.
I have to message in the chat. I have been waiting here for last 35 minutes. Like, kya, sir, kya?
One second. Yes, I'll just share my screen as well. All right. So yeah, finally. I mean, your video was not working, man. What can I do about that, huh? Your video was not working from that time. All right, anyways. So, people, please say hi to the auntie of the year, Bhavna auntie.
Hi, everybody. How's preparation going? Finally, this is the final lab. Science exam kal hai aur aaj aap bahut अच्छे से पढ़ रहे हैं. Right? Don't worry about any confusion. There are going to be doubt classes in the evening for both, like physics, chemistry, and bio. So, tab Anoop sir ka pura sir khana. Fine discovery science. Fine.
Absolutely, ma'am. Absolutely. All right, so guys, we'll go on to the next question. Bhavna, you can please go ahead with this question.
Distinguish between a solenoid and a bar magnet. Draw the magnetic lines for both. Now, this is one of the easiest question. If I say this is like a theory question which you guys already have. So when I have such kind of a question, I just say they are like brothers from another mother. Solenoid and bar magnet have the same kind of magnetic field. So the second part of the question becomes super easy, right? The only difference that will come here is what? When you have to draw the magnetic field lines.
Ma'am, 1 sec. The video is lagging. There's a lot of lag. Ultra lag. Okay. Super ultra lag. 1 sec. Let me just sort this out, guys. I don't know what's happening. I don't know. What sort of bad luck is this, ma'am? Every time you join, only all of this happens. Until now, it is perfectly fine. Until now, it is perfectly fine. There's no problem at all. I mean,
very good.
Students can vouch for it. Right now, people. Until now, it was all perfectly fine. Ma'am joined, that's all. Everything is gone. 1 sec. Let me just check my internet speed again.
That is like my issue, because Anoop Sir's internet is on
Yes. Oh my God. I'm not able to hear you at all. Your voice is breaking like crazy. Just give
Who
me
made you the physics teacher? Logic का है
one sec.
आपका.
Okay, yeah. Finally,
Okay,
huh.
just kidding. So
Fine.
people, talking about this.
Bhavna ma'am, your voice is lagging
Can we
like
do this?
crazy. One sec.
Solenoid and bar magnet. Let me just see if that is still an issue.
Yeah,
Then
now
we
it's
will
fine.
just now
Supreme
it's
fine. Now it's
Everybody?
fine. Now it's fine.
Fine. Okay, cool. Okay, I am listening to Anoop Sir now. It's the people are still saying lag. If it is still lagging, then we can stop.
Yeah, exactly. I know, right? Oh, I am the problem. Exactly. As last time also when you joined, started lagging. Now also again it's lagging. Why, ma'am? Why?
Net speed is working fine now.
Yeah, my net is good only. My net
Your
is good.
Zoom might have an issue out there.
Yeah,
maybe.
probably. But yeah, my net is fine. But anyways, yeah, please continue, ma'am. Ultra lag again, lagging. No, array.
If I'm lagging, then it's not good, na? Then you should continue with this. You shall go. I'll see later then.
All right, what to do, ma'am? All right, I'll call you back at the end then. We'll join at the end. Yeah,
No
ma'am?
problem. No problem. I'm
All
here.
right.
Just ping me once.
Yeah, sure.
on camera.
So guys, Bhavna would be there, but unfortunately because of lag issues, we'll have to end for now. I'm really sorry for this, but क्या करें अब क्या करें हमारा time itch ऐसा है. What did I don't know, for some reason whenever ma'am joined there's ultra super pro max lag happening. But yeah, anyways, let's continue, guys. Let's continue. We have you have also a biology session starting after this. I'll just check my internet speed one last time now. After this we'll move on to the question. All right. Okay, so people, 18th question, very simple one. Let's go ahead and do this. And in the meantime, Bhavna ma'am would also be answering you guys in the chat box. She'll be there with you guys, so you can talk to her on the chat. She is anyway sitting Vela over there, so you can talk to her. All right. Insult, just like that. All right. She's sitting Vela itself, so you can talk to her. No worries. All right. I'm a setting over there only. All right. So here's the question: distinguish between a solenoid and a bar magnet and draw the magnetic field lines of both. Now, people, please remember, it's a 3-mark question, right? It's a 3-mark question. So mention at least 3 to 4 points. At least 3 to 4 points you need to find out. All right. First thing first, explain what a solenoid is and explain what a bar magnet is. A solenoid is nothing but an insulated copper wire which is wound to make it look like a cylinder. You can mention it that way, or you can say that a solenoid is basically a several circular copper wires or insulated copper wires, or several turns of copper wires put together to make it look like a cylinder. Now, whatever you choose to whatever way you choose to explain it, it's absolutely fine. Again, I think there's a lag again. One sec, guys. Why is this happening? Every time ma'am comes and leaves, lag only. Lag only. Okay, wait. One sec. Again, lag. Why? Bhavna ma'am, what sort of curse is this? Huh? Scold Bhavna ma'am in the chat box. Blame Bhavna ma'am only, not me. Blame Bhavna ma'am, I'm telling you. Until now it is perfectly fine. Wait, now I think it's fine. Now yes, it's fine. All right, okay, let's go on, guys. Let's go on to the next question. All right, so as I was saying, solenoid is basically several turns of insulated copper wires put together to make it look like a cylinder, or you can say it's nothing but an insulated copper wire which is wound to make it look like a cylinder. That is what is a solenoid basically. A bar magnet, on the other hand, is a permanent magnet. It's a permanent magnet which has fixed polarities, and basically it's something where you can't change the magnetism also. Now that is what is a bar magnet is a permanent magnet. All right, it's a permanent magnet. That is what is a bar magnet, which looks like a rectangular it looks like a rectangular magnet. That's what a bar magnet is. It's a rectangular magnet which has fixed polarity, and it's a permanent magnet. Now, talking about the difference between the two, if you talk about the difference, I'll just write down the points. I'll just write down the the keywords. Please make the points later, people. So the keywords here are, people, a solenoid is a electromagnet or a temporary magnet. All right, it's an electromagnet, or you can say that it is used to make electromagnets. All right, you can say that it's used to make electromagnets. It's a temporary magnet. A solenoid is a temporary magnet. It's a temporary magnet, whereas a bar magnet is a permanent magnet. A solenoid is, in a solenoid you can actually increase or decrease the strength of the magnet. The strength of the magnet is adjustable. You can increase it or decrease it according to your wish and will. All right, the magnetic strength is something which is changed. You can change it, you can adjust it over here, but here the magnetic strength or the magnetic field is fixed. You have a fixed magnetic force, or magnetic field around a bar magnet. Thirdly, the polarity of a solenoid can also be changed, because the polarity depends on the direction of current. So if direction of current changes, the polarity will also change. So polarity of a permanent magnet cannot be changed, whereas a solenoid's polarity can also be changed or can also be reverted or inversed. But here on the other hand, you have fixed polarity. A fixed polarity, you can't really change the polarity. Apart from that, you can also mention that solenoids are used to make electromagnets by placing a soft iron core into it. Bar magnets, on the other hand, you cannot make electromagnets out of it. So these are all the difference between a solenoid and a bar magnet. Again, the notes are downloadable. I'm going to tell it again, people. You can download the notes later, so don't worry about it. All the theory, I know that a lot of it, I'm just writing simple, the keywords alone, but don't worry, the entire notes are downloadable, so you can download the notes later and refer to it whenever you want. All right, so don't worry about that as well. And if you talk about the last part, basically talking about the magnetic field lines, if you were to draw the magnetic field lines, this is what it looks like. It's very similar for both of them, both bar magnet and solenoid. The one key similarity is that the magnetic field around it is very similar. You'll have magnetic field lines originating from the North Pole and ending up in the South Pole. So it's very similar to that of a bar magnet for a solenoid as well. Starts from the North Pole, ends up in the South Pole. Inside, on the other hand, the magnetic field lines would be going from south to north. So you just need to remember that much. All right, so this is the difference between a bar magnet and a solenoid. 3-mark question, easy peasy. Aram se easy question, you can easily put in your pocket and walk around. All right, 19th question, people. 19th question, let's go on to this one as well. Very important, because again, this type of question has been repeated several times, and you would definitely have these kind of questions in your boards as well. The question is, how can 3 resistors of resistances 2 ohms, 3 ohms and 6 ohms be connected to give a total resistance of 4 ohms and 1 ohm? A beautiful question. Again, this type of question you can definitely expect in your boards, because it's more of a practical question, more of an application based question than giving you a direct one. So please pay attention, give your best. So go ahead and put it down, people. Let's go. Sorry, Anoop Sir ne popper kar diya hai. हाँ, yeah, Bhavna Mam. Blame it all on me. Blame it. You know, see, people in life also, you'll have people like this. All right. Don't. All right. Bhavna auntie is a good example for that. All right. Let's go. All right. Again, Tarun, yeah, please. I think the answer, Bhavna would be better to answer that. But yes, I would just say this, that in a solenoid, the magnetic field line inside the solenoid is stronger than the poles. Please remember that. All right. Inside, you can mention that also, Kushagra. So you can mention that also. Again, you can mention at least 3 to 4 points. You can mention that also. The 4th point, you can mention that the magnetic field inside the solenoid is much more stronger, whereas in magnetic field of a bar magnet, near the poles, it's stronger. So near the poles, it is stronger for a bar magnet, and for a solenoid, it's stronger inside the solenoid. All right, inside the solenoid is where the magnetic field is much more stronger. All right, moving on, guys. 19th question, please put it on the chat box. How would you connect these resistors, 3 resistors, 2 ohm, 3 ohm and 6 ohms in order for you to get an equivalent resistance of 4 ohms and then 1 ohm respectively? Let's go, people. Let's go quickly. Put it on the chat box. Let's go. 2, 3 and 6 in parallel and 2 in series. Arre Rajan ji, awesome. Arre, awesome. Absolutely, guys, absolutely. For the first one, if you want a 4 ohm resistor, see, this one in particular, guys, is all trial and error. If you do not know how to do this, you have to do trial and error. You have to try out different combinations and see what works best. Now, in this particular scenario, people, for 4 ohm resistor, you can directly say that, you need to connect 2 of them in parallel and 1 in series. Now the question is, which of them would you connect in parallel? Which of them would you connect in series? Now the answer for that is that you would be connecting the 3 ohm resistor and the 6 ohm resistor in parallel, and you would be connecting the 2 ohm resistor in series. I'll tell you why. Because when you calculate the equivalent resistance in this scenario, in this particular case, when you calculate the equivalent resistance, all right, how do you calculate it? It's 1 by R equivalent is equal to 1 by R1 plus 1 by R2, which is equal to 1 by 3 plus 1 by 6. So into 2 into 2. So it's 2 plus 1 divided by 6, which is equal to 3 by 6, which is going to give you, this is going to be what? This can be written as 6 by 3, which is equal to 2 ohms, right? 2 ohms is what you get. This is the equivalent resistance. Now that you found out the equivalent resistance in this scenario, all you do is find out what? Add them both, add these both now. So this whole thing is 2 ohms plus 2. So what is the equivalent resistance? R equivalent, R total, you can say is a 2 plus 2, which is nothing but 4 ohms. Simple. Now for the second one, on the other hand, I'm going to change my screen size over here again, people. So if you want to get the total resistance of 1 ohm, all you have to do is this, people. See, you just need to remember this one thing, that is, when you have 3 resistors, 2 ohms, 3 ohms and 6 ohms, please remember that when you connect them in parallel, the equivalent resistance will always be less than the individual resistance. Now here, very clearly, 1 ohm is lesser than any of the individual resistors. 2 is greater than 1, 3 is greater than 1, 6 is also greater than 1, which means that directly, even without any calculation, you can directly say that you just have to connect them all in parallel, connect them all in parallel. As simple as that, because when you connect them all in parallel, you will get the equivalent resistance to be less than the individual resistance, which means that you will get it as 1 ohm itself. So here, when you calculate it, it's 3 ohms, this is 3 and this is 6. So it's going to be 1 by 2 plus 1 by 3 plus 1 by 6 calculated. So it's going to be 2, 3, 3, 2. So it's 3 plus 2 plus 1 whole divided by 6, which is equal to 6 by 6. Again, reciprocated 6 by 6 itself, it's going to be 1 ohm. Simple as that. You don't even have to calculate it. All directly. So if you see the value of the equivalent resistance less than the individual resistance, then without calculation, you can directly say that that is basically connected in parallel. Simple as that. All right. All right, guys. Finally, after about 1 hour, I think it's been about 2 hours since I've come online now. We've been talking for about 2 hours. I think it's been about 1 hour 40 minutes at least. Finally, after 1 hour 40 minutes, we are on to the 20th question. Let's do it. All right, let's quickly do it. The 20th question, people. Here it is. An electric heater draws a current of 10 amperes from a 220 volt supply. What is the cost of using the heater for 5 hours per day for 30 days if the cost of 1 unit is 2 rupees 50 paise? Super easy question. Direct answer. I am not even going to talk about this anymore. You guys put it down in the chat box. Let's go. So why does the magnetic field in solenoid stronger near the poles when we insert a soft iron core? Because Ashwath, the reason is because the soft iron core also gets magnetized. The soft iron core also becomes magnetized because of the current flowing around it, because of which the whole thing behaves like a magnet. That is why it becomes stronger near the poles at that time. All right, because that would act like the north and the south pole, because the soft iron core also gets magnetized. That is the answer for that. All right, we have about 5 more questions left. That's all. We have 25 questions in total. So after this, we'll move on to the 4 markers. There are very few 4 markers, so let's do that also very quickly, guys. Let's go. Is it? Arey Sacheli ji, such bad luck, no? Sacheli Matthew, such bad luck. You're in Bhawna Mam sessions. Arey, such bad luck. I feel sorry for you, but what to do? All right, let's go, guys. Let's go. Let's go. Let's go quickly. I know, right? Bhavna ji, ki ho gaya? All right, let's go now. Quickly put it out in the chat box, people. We have not much time left. Let's go. Because you have the chemistry, biology marathon also starting right after this, so you have to finish off before that. Done, pakka, 100%. All right, let's try to do this, guys. So here, people, what and all is given. Current is given as 10 ampere. Awesome. Potential difference is given as 220 volt. Awesome. Time, it's run for 5 hours a day. All right. So first thing first, people, find out the power. Right? Find out the power. All right. So power is what? Power is equal to voltage into current. That is what? 220 into 10, which is 2200 watts. Convert this to kilowatts. So divide this by 1000. You'll get it as 2.2 kilowatts. Simple. Now find out the energy consumed. Energy is equal to what? Power into time, which is equal to what? 2.2 into 5 hours. It's running for 5 hours a day. So 5 2s are 10, 5 2s are 10 again. So it's going to be about what? I think 11 watt hour. Or, no. 11 watt hour. No, it's going to be 11. My bad. Sorry. 11 watt hour. Right. 11 watt hour. 11 kilowatt hour, sorry, 11 kilowatt hour is the total energy consumed. 11 kilowatt hour is the total energy consumed. Now people, the thing is, this is per day, 11 kilowatt hour per day. You have to calculate for 30 days. So how will you calculate that? So total energy consumed, E total will be equal to 11 into 30 because you're running it for 30 days every day. So that's going to be how much? 330 kilowatt hour, if I'm not wrong. 330 kilowatt hour, that is the energy consumed for the whole month. If that is the case, how will you find the cost? Simple. Cost is equal to total energy consumed into the cost per unit. Cost per unit, which is equal to, this is the total cost, all right? That is equal to what? 330 into 2.50, which when you calculate, you will get it as how much? 825 rupees. That's it. All right, fantastic job, people, fantastic job. So that is the answer for the 20th question as well. Now people, let's go on to the 4 markers. But before that, once again, let me ask you this question. Are you guys feeling a little confident now? Yeah, all good now? Everything awesome? Enjoying the session so far? Yes. Are you guys finding this helpful? Are you guys finding the marathon session helpful? All good? All awesome? Done? Good questions? Yes? Done? Last type of questions, the 4 markers, which is going to be a little lengthy, which means that you have to be, you have to spend a little bit more time on explaining these concepts as well. Make sure that you, put a little bit more effort into that, in the sense, while you're giving your, examination, make sure that you, give a little bit more deeper explanation into all of these, so that they don't get, cut any marks at all. All right, make sure that you write it in brief. Again, as Bhavna Mam told in the yesterday's session, no, you should not let the examiner, you should not give any chance to the examiner to cut even half a mark, right? It's important. Every single mark counts, guys. Every single mark matters. That is going to, 1 mark could be the difference between you becoming the school topper or getting, 90% or 80%. All of that matters. So make sure that you give your 100%. Make sure you be as brief as possible, as detailed as possible, especially when it comes to the 4 markers. All right. Okay, people, here is the 4-mark question. The first 4-mark question, the 21st question for today. 2015 board exam. 2015 board exam question. This is the question is, what is meant by electric current? Name and define its SI unit. In a conductor, electrons are flowing from A to B. What is the direction of the conventional current? Give justification for your answer. A steady current of 1 ampere flows through a conductor. Calculate the number of electrons that flows through any section of the conductor in 1 second. If the charge of electron is 1.6 into 10 to the power of minus 19 coulomb, find out how many number of electrons are flowing if the current is 1 ampere. Fantastic, fabulous question. Please start putting down in the chat box, what is meant by electric current? Let's start with that. What is current? How would you define current? Let's go. All right, let's go, people. Let's go. Only when I see the first question of science board, you will. See, the thing is that I understand the anxiousness that you have at this point of time, that you guys are all waiting for your, board exam. The first question of your board exam is going to decide how it's going to be. But I would just say this, even while you're, entering into your board exam, entering into your class, make sure you stay calm. All right, it's important that you keep your mind at ease, focused. All right, make sure you keep your mind focused and stay calm. All right, exactly, people, exactly. What is current? Current is nothing but the rate of flow of charge. Rate of flow of charge is what is called as current. It is nothing but rate of flow of charge. Now, name and define the SI unit. The SI unit basically of current is what? Current is nothing but rate of flow of charge. It's nothing but Q by T, which is nothing but coulomb per second. So the SI unit of current is nothing but coulomb per second, which is also written as amperes. All right, which is represented by the letter capital A, which is nothing but amperes. Now, this is basically going to give you about 1 to 2 marks. Now, the next part of the question is, in a conductor where the electrons are flowing from B to A, there's a wire, the current is flowing from B to A. What is the direction of the conventional current? If the electrons are flowing from B to A, what is the direction of conventional current? And also justify why that is so. Exactly, ampere, guys. Absolutely. Coulomb per second is the SI unit, which is also written as ampere. All right, please remember this. It is coulomb per second, which is also written as ampere to honor and ray ampere. All right. Okay. Now for this one, guys, what is what is the direction of conventional current? Put it on in the chat box. Exactly, Delcy, exactly. The current's direction, people, the conventional current will be in the opposite direction. So conventional current will be from A to B, not from B to A. Why? Because conventional current is taken as the flow of the positive charges. So if electrons are flowing from B to A, the positive charges would be flowing from A to B. So that is the direction of current that we take. So the conventional current direction would always be opposite to the flow of electrons. Now, why is that so? Because again, people, I told this in the in the regular sessions in the Prodigy series, that because the invention or the discovery of electrons happened a little too late. By then, we had done a lot of experiments and nobody knew that electrons existed until that time. So because of this, we still consider to follow that, to avoid confusions, we keep it, or we consider the conventional current, which would always be opposite to the flow of electrons. All right. So conventional current, since current is the electrons are flowing from A to B, current will be from A to B. That's it. All right. Okay. Now for the second one, people, if a steady current of 1 ampere flows through a conductor, calculate the number of electrons that flows through any section of the conductor in 1 second. If the charge of an electron is 1.6 × 10⁻⁻19 coulomb, find out the number of electrons. Fabulous question. Firstly, guys, for this question, what would be the formula that you're going to use? For this question, what formula would you be using? Let's go, people, let's go quickly. Put it on the chat box. Jaldi karo, jaldi. What would be the formula? All right, let's go, guys. Quickly now. What is the answer for this one? Which formula would you use to find out the number of electrons that is flowing through a point? Exactly, guys. Exactly. Very fabulous. So the formula that we use, guys, is that Q is equal to N into E is the formula that you're going to use. Now we know that, they have given you that the current is 1 ampere. So we know that, I is equal to Q by T. So this is nothing but what? Q is nothing but NE by T. So current is nothing but 1 ampere. This is what N is N is what you're supposed to find out. And E is nothing but the charge of an electron, which is 1.6 × 10⁻⁻19 coulomb, whole divided by 1 second. So now, people, calculate the rest. Take this to the other side. So N is equal to 1.6 × 10⁻⁻19 whole divided by 1, which when you calculate, you will get the answer as 6.6 × 10⁻⁻19, if I'm not wrong. 6 into 6.8 or 6, what is the value now? 6.2, sorry, 6.2 × 10⁻⁻19 it would be the answer. -18, 6.2 × 10⁻⁻18 electrons would be the answer. All right, 6.25 into 10⁻18 electrons would be flow. All right, you can remove the minus sign also. You can take it as plus itself, because when it goes to the other side, it will be plus. My bad, it will be plus, guys, because when you take it to the other side and take it to the numerator, it will become plus. So it's going to be 6.25 into 10⁻18 electrons. All right, just to erase this, I'll just write it cleanly over here. All right, people, 1 second. Talking for the past 2 hours, is like, it's exhausting. 6.25 into 10⁻18 electrons would be the answer. All right, so that is the answer for that particular question. Moving on, people, let's go on to the 22nd question now. Again, a 4 marker. Let's go ahead and do this one as well, people. 2014 board exam, this particular question was asked. So pay attention. Again, previous year question papers. If you haven't done it, we are pretty much covering all the question papers, all the kind of questions that has been covered in the past years. So make sure you stay and get this solved as well. The question is, 2 wires A and B are of equal length and have equal resistance. If the resistivity of A is more than B, which wire is thicker and why? And for the same electric circuit given below, calculate the current in each resistor, the total current drawn from the battery, and the equivalent resistance of the circuit. Now the fact is, guys, the same question we have done, the same circuit we saw it before also, same calculation, no change whatsoever. But for this question, again, it's not just that part, it's not just that particular portion. You have to also find out what is the which one would have greater thickness if in case there are two resistors or two wires which has same length, same resistance, but have different or of different material or have different resistivity. All right, so put on in the chat box, people. Let's go. Let's go. I know. All right, let's go, people. Let's go. Come on, put on the chat box now, quickly. Full Josh. Let's go. Which wire would have greater thickness if in case? Which wire would have greater thickness if in case the resistivity of A is more than that of B? Let's go. A is thicker because our rho is directly proportional to the area. Okay, now pay attention, guys. Pay attention. See, guys, in both the case, length of A and length of B is equal. Resistance of A and resistance of B is also equal. Alright, but the resistivity of A is greater. Resistivity of A is greater than the resistivity of B, which means that so if you look at the formula, R is equal to rho into L by A. Since length is equal, you can say that R is directly proportional to rho by R is directly proportional to the resistivity and inversely proportional to the area. Now, if that is the case, you can say that, see, resistance and resistivity is directly proportional. So if resistivity is high, resistance will also be high. Now here, since both of them have the same resistance and resistivity of A is much more higher, you can say that A would have greater area. The area of A would be much more higher than area of B. Why? I'll tell you, people. Because if the area is more, resistance is less, because resistance and area are inversely proportional. Resistance and area are inversely proportional to each other, which means if area is more, resistance will be less. If that is the case, for the first one, where the resistivity is higher, you need to have greater area so that more current can flow through it, so that the resistance becomes less. So very clearly, guys, A will have greater area of cross section than B. Got it? Is that clear? Please do remember this. You have to prove it. You have to show these calculations. You have to write down the relationship. You have to show that resistance is inversely proportional to area. Resistivity will also be inversely proportional to area. So you can say that greater the area, lesser the resistance, and hence you can say that A will have greater area of cross section than B because the resistivity of A is more. Alright, so that is the answer for that question. Now for the second one, people, calculate the current in each resistor. We have done the exact same question before also, so I'm not going to do much calculation. Guys, again, we have done the same question. If you remember a couple of questions ago, we did the exact same question. I believe this was asked as a 2-marker or a 3-marker. So go through the notes will be uploaded so you can go through it. The exact same question, same current value, same thing. You have to find out the equivalent resistance, find out the current. Easy peasy. I think you can do it. Yes. Do you want me to solve this question, people? Do you want me to solve this question? We've already done this though. We've already done the same question. So do you want me to show it again? Clear, no? So electric generators. Yes, Krishna. Absolutely yes. Electric generator is not there. Absolutely. But you have electromagnetic induction though. So please go through that. Alright. So I'll just move ahead, guys, because we have done the same thing. Okay. You have not seen the circuit? People, it's the same circuit. We have done the exact same thing before. 30 ohms, 10 ohms and 5 ohms. We did the exact same thing. So you'll get the answer from your previous question because the same thing is done. All right. Didn't understand, Ranjan? All you have to understand is this. It's like this. Okay, I'll just give you a simple example. Look at this water bottle right now. Look at the cap of the water bottle. All right, I want all of you guys to focus. For all those who are confused about resistivity and resistance and all, just pay attention for 1 second. I want all of you guys to look at the lid of this bottle. All right, it's pretty narrow, right? So if I start pouring out the water, if I just invert it and start pouring out the water, right? If I start pouring out the water will start flowing out. let's say that I have another bottle, which, let's say I have a mug now. Instead of a bottle, I have a mug now. All right, a jug or a mug. Now, if I open the lid of the jug and start pouring out water, the same amount of water, through which of these containers, through the bottle or through the jug, will the water come out fast? Which of them will become empty faster? This one, the one which has a little thinner cap, or the one which has a wider mouth? From which of these water will come out really, really fast? Which of them will become empty really fast? Which one? Think for a second. The jug, which is completely open, or I think I have one sec, people. Let me see if I can show you guys. Okay, my bad. Okay, this one. All right, let's take this one for example. This one, or this one? This one, right? Why? Because it has greater area of cross section. It has greater area of cross section, right? It has greater area of cross section, which means what? More current will flow through it. So if both of them, out of the two, if one has greater resistivity, which means the material itself is providing a lot of resistance, this one is a better conductor and this one is a bad conductor. If this is already is having a lot of resistivity, you need to increase the area, right? So that current will flow easier, so that you can maintain the same amount of resistance in both of them. Yes or no, people? Are you able to understand this? This has higher resistivity. It is naturally a bad conductor in comparison to this. So in order to make sure that both of them have the same resistance, I need to increase the area. I need to increase area so that current will flow much more freely. Got it? Is that clear now? Now is it better? I hope you understood this now. So this is one of the easier way to understand it. Clear? So that's how you can say that A should have greater resistivity. I hope it makes sense. All right, moving on, guys. Moving on. I hope we have done the same question before, so I'm going to go ahead because I don't want to waste much time because we've already done this. So I'm going to go to the next question. 23rd question, people. So the answer is this, it's given right here. So I1 is going to be 1.2. We have done the same calculation before. I2 is 0.6. I3 is 0.2. So if you add them all up together, you'll get as 2 amperes. So 1.2 plus 0.6 plus 0.2, you'll get the total current to be 2 amperes. All right. So equivalent resistance also you can find out 1 by 30 plus 1 by 10 plus 1 by 5. You will get the equivalent resistance to be about 1 by 3 or 3 ohms. All right. When you reciprocate it, you'll get as 3 ohms. We have done the same question, so I'm going to go ahead. All right. Okay, guys. Next question. 23rd question. This particular question is taken from NCERT question bank, CBSE 2012, 2014, and 2015 question paper. The same question has been repeated. The question is, what is Joule's law of heating or Joule's heating effect? List the application of Joule's heating effect in your daily life. Mention at least 3 to 4 examples of Joule's law of heating. Mention again, it's a 4-mark question, so you have to be a little brief when you explain this. So let's start with the first one, people. What is Joule's law of heating or Joule's heating effect? Let's go quickly. Let's go. Understood? No, that's all. Simple answer. All right. Okay. Quickly, guys. Quickly put it on the chat box. What is the answer for this question? If you have, if you have to explain Joule's law of heating, how would you go about doing so? Let's go. Quickly. 12:30. You have your biology marathon also. So before that, we have to end this, guys. So let's go. Quickly put it on the chat box. Exactly. Joule's law of heating states that, guys, heat energy produced in a circuit is directly proportional to the square of the current flowing through the circuit. Heat energy produced in a circuit is directly proportional to the time for which the current is flowing through the circuit, and heat energy produced in a circuit is directly proportional to the resistance for which, greater the resistance, greater the heat energy produced as well. So once you write in the formula H is equal to I square RT, please explain them individually. Explain them. So heat energy produces directly proportional to the square of the current, heat energy produces directly proportional to the resistance, and heat energy produces directly proportional for the time for which the current is flowing through the conductor as well. So mention that as well. Explain it, write it in sentence also. You need to do it because it's a 4-mark question. Be as brief as possible. Alright, now to talk about the application. Where all do we use Joule's law of heating? The question is, where do we not use Joule's law of heating? Joule's law of heating is used in your iron box, room heaters, Water heaters, it is used in your induction cookwares, in anywhere and any place where there is heat generated. We use Joule's law of heating. But again, guys, please explain it. Like for example, in room heaters, we have something called the element. So what happens is when current is flowing through the element generally has high resistivity. Since the resistivity is high, the resistance will be high. Since the resistance is high, the heat generated will also be much more higher. In the case of water heaters, also it's the same thing. We use an element like nichrome is generally what is used. So nichrome is the common element that is used. Nichrome has very high resistivity, and since it has higher resistivity, it has higher resistance. Since the resistance is high, heat generated will also be much more higher. All right. So again, explain it in brief. Again, the notes can be downloaded. So they have mentioned, the electric iron, and they've also mentioned about electric geyser and electric. You can also give the example of electric bulbs also. The filament bulbs, even the filament bulbs, which is made up of tungsten, also works on Joule's law of heating itself. When current is flowing through it, more heat is generated. Because of that, there is light and heat produced. All right, exactly. Tungsten is also a good example. Alloy like nichrome is also a very good example for Joule's law of heating. All right, so that, my friends, is the 23rd question. 2 more questions and we're done. How are you guys feeling? Before we go to the next question, can we have 500 likes? About 200 students are watching it live. Can we go hit the like button and make it 500 at least? We have reached 467 without even asking. Thanks a lot for that. But make it 500, guys, so that I also get some motivation. All right, 2 hours continuously I'm sitting and talking. No, 2 hours I've been sitting and talking. No, hit the like button. The like button. Kanjusi Q. Kanjusi Q. I'm not asking you to pay money. No, hit the like button at least. Let's go. Done? No? Thank you, people. That's the spirit. All right. 24th question, guys. 24th question. Let's go for this one as well. The question is pretty long, but the answer is quite simple. The question is, when a high resistance voltmeter is connected directly across a resistor, its reading is 2 volt. An electric cell is sending the current of 0.4 amperes measured by an ammeter in the electric circuit, in which a rheostat is also connected to vary the current. Draw the equivalent labeled circuit diagram for the given data. Find the resistance of the resistor and name and state the law applicable in given case. A graph is also given between a set of values of potential difference across a resistor and current flowing through it. Show the nature of the graph, thus obtain a beautiful question. Nice. Love this question. 4 mark. Thanks a lot, people. Thank you for that. I don't know. I'm not able to see your chats on time now. I'm seeing your chat after like 5 seconds. All right, let's go. Exactly. इतना कॉन्फिडेंस तो कौन देगा? हम दे रहे हैं ना, हम दे रहे हैं कॉन्फिडेंस. देखो कॉन्फिडेंस देखो जी. Alright, okay. So for the first one, guys, how do you draw this electric circuit? See, guys, they have given a resistor. Alright, there's a resistor to which there is a voltmeter connected. There's an ammeter also connected. There's a rheostat connected, and obviously there's going to be a battery and a key as well. So if that is the case, how would you connect this circuit? First thing first, draw the battery. The battery is then connected to the key. The key is then connected to the ammeter, because ammeter is always connected in series. The ammeter is then connected to the resistor. Now if you look at it, they have also told that there is a voltmeter connected across the resistor, which means that there has to be a voltmeter over here also. So there's a voltmeter right about connected parallelly to the resistor. Now, it doesn't just end there. They're also telling that there is a rheostat also connected. How will you draw the rheostat? Draw the rheostat like this. This is the symbol to draw a rheostat. And my friends, this is the connection. Now, to make it even more, to show the invigilator, the examiner that you know all of it, you can also mention the polarities, just like how Bhawna Mam will do it. So mention the polarities as well. This is the positive terminal, this is the positive terminal. This should also be positive, this should also be negative, because ammeter and voltmeter, in that there is a polarity. So you need to connect positive to positive itself, negative to negative itself. So you can show the polarity also. But resistors don't have polarities as such, so you can mention it like this. Alright, so this, my friends, is the answer for this question. Alright, now you have done the diagram. Now find the resistance of the resistor. How will you find the resistors? See, the value of the voltage is given as across the resistor is given as 4 volts. The current value is given as 0.4 amperes. Very simple, people. According to Ohm's law, we know that R is equal to V by I. That is V is equal to I into R. So R is equal to V by I. Substitute the values over here. It's going to be 2 by 0.4. So into 10, that is 20 by 4. 4 5s are 20. So it's going to get it as, you'll get it as 5 ohms. So this resistor has a value of 5 ohms. Simple. Now for the last one, guys, name and state the law applicable in this case. The law is what? Ohm's law. State Ohm's law as well. Ohm's law states that what? As you know, in a certain circuit or in a given circuit, the current flowing through the circuit is directly proportional to the potential difference as long as the temperature is kept constant. Alright, as long as the temperature is kept constant, the current flowing through the circuit is directly proportional to the potential difference. So mathematically speaking, you can say that V is directly proportional to I, which when you put the the value that is a constant, you can write it as V is equal to I into R, where R is the resistance, which is nothing but the constant that is introduced to remove the proportionality sign. That's it. All right. Lastly, people, they've also asked you to find out the graph as well. You're basically, they're asking about VI graph. So for the last part of the question, the last part, D part of the question, the graph would look like this, where voltage and current are basically, voltage is put up in the, on the Y axis and current in the X axis. So in this particular scenario, when you draw the graph, that is for Ohm's law, the graph would look like this. It's basically nothing but a straight line, a line. You can say it's a straight line which shows that as the voltage increases, current would also increase. All right, clear, people? Understood? So all of this, when you write, you would be getting 4 marks. All right, so each part would carry 1 mark each. So this is 1 mark, this is 1 mark, 1 mark, 1 mark, 1 mark, and this will also give you 1 mark. That's it. All right, exactly. It's a linear curve. Exactly. All right. You don't have to find out the rheostat value. Right? They've not asked for rheostat value. They've not asked for it, so you don't have to. They've only asked you to find out the value of the resistance. That's all. All right. Find the value of the resistor. That's all. They've not asked you to find out the value of the rheostat. No. So you don't have to. All right. Why to waste extra time? 4 mark question. Keep it simple. That's all. All right. You don't have to. They have not asked for it. If they had asked you in particular find out the value of rheostat, then you could have. But they have not asked you for it, so you don't have to. All right, don't do it. Okay. All right, guys. So this is the answer. You can find the notes over here. The last and the final question, people. 2008 CBSE board exam question is this. This is the one. Last question, people. That's all. Nothing else to do. 2 hours. We have done it, 2.5 hours almost. We've almost done it. Last question. Go ahead and answer this one, people. 2 lamps, one rated at 60 watt and 220 volt, and the other rated at 40 watts and 220 volts are connected in parallel to an electric supply of 220 volts. First one, draw a circuit diagram to show the connection. B, calculate the current drawn from the electric circuit or electric supply. And C, calculate the total energy consumed by the 2 lamps together when they are operated for 1 hour. Beautiful question. Amazing numerical. Go ahead and do this, people. In the meantime, please try to do this, solve this question. In the meantime, I would be, bringing back our very own, Bhavna auntie in the meantime. Let me see if I can, wait a second. Let me just see if I can host a meeting where Bhavna Mam or Bhavna Auntie Ji can also join. In the meantime, people, please put on the answer for this question. I have put, okay, you guys can't see the question. No, you're not able to see the question. So this is the question, people. Please try to solve it. I hope you guys can see the question now at least. I'll, send this link to our very own Bhavna Ji. Bhavna Ji is waiting from that time. So let's call Bhavna Ji also into the meeting. In the meantime, you guys can solve that question. All right. 1 sec, please. All right, Bhavna Ji, if you are watching the session, please join it. In the meantime, all of you guys, please try to solve this question as well. Where's the question? All right, so here's the last question for today, people. Go ahead and solve this one. 2 lamps rated at 60 watt and 220 volt and 40 watts and 220 volt are connected in parallel. Find out again. Yes. Bhavana ji, at least this time, I'm hoping that, I'm hoping that it's going to be all right.
बाल धोने बैठी थी, मेरे बाल सूख गए. I've been waiting for so long.
What can I do? You and your internet, no? It's like,
My internet.
yes.
How could it be my internet? You are the host.
So what? It's still, I have to still blame you only. I can't take the blame for it.
अरे मतलब you have to, because last time you made me the host because your internet
Exactly.
is not.
The last time, but this time my internet is good, ma'am. What is this, huh?
So you upgraded, huh? For
Exactly.
you're
One day
upgraded.
itself I upgraded everything. Okay, and guys, I hope you guys can see this, right? Now I hope everything is clear now. All good? Alright. You guys can hear everything. No, now it's better. No? Now you can hear Bhavna auntie. No? Alright, great. Alright. So people, let's go on to the last question. Bhavna auntie ji, why don't you do it? Alright.
Please show me the last question. I'm not
Alright,
able to
here is
see.
the question. Are you not able to see it? Okay, one sec. Oh, yes. One sec. Yes, Bhavna ji, yes. Now you can see it, no? Yeah.
Okay, so this is the last question for this. I hope everybody is doing good, and let's start with this. Two lamps, one rated 60 at 220 volt and the other is 40 at 220 volts are connected to parallel with the same supply. So this is one of the questions that we have already seen, and might you guys have done this like many times, because this is related to power connected in parallel with the same voltage. Now this is one question that I was reading in the chat जब मैं answer भी कर रही थी कि why or which formula to go for power when we do not know which kind of circuit. So it all depends what is given. Here we already know it's a parallel kind of circuit, so it becomes easy that which formula we have to apply. Right? I'll just tell you, but वो मैं बाद में बताऊंगी, आप लोग पहले बताओगे. Come on kids, in the chat, can you tell me which formula we should go here with? Come on, finally I'm in, finally. Yes, आ गई नंदिता, मैं आ गई. Okay, quickly, which formula are we going to employ? I'm not asking anything else, I'm just asking if this kind of a question comes, then which formula will you go with? Come on, everyone. Come on, क्या हो रहा है ये? रो ब्लॉग करना, व्हाट इज दिस? रविंद्र क्या हो रहा है? पढ़ाई से मन खत्म हो गया तुम लोगों का? हाँ, एंड में आते बच्चे पेपर अभी भी कल ही है. Your
exam is still tomorrow. I know exactly. Exam is still not done yet. You guys are chilling.
But it's okay to chill in between, but do not lose your focus. ठीक है? So ideally this is the first part where they are asking you to make the circuit. So always go with the circuit with your own hand. As already told, it gives you the confidence. Okay, now I know the circuit. So there are two lamps. It's very simple. मेरा bulb tree ज़्यादा लगता है और bulb ज़्यादा कम लगता है, but ठीक है, you can draw it better than me obviously. And this is what is it? Two parallel. One is for 60 watt. One is for 40 watt. They both are connected to 220 as in parallel. So I do not have to draw another. Yeah, I can draw one single 220 volt battery. This is my simplest of the circuit. अब इसे थोड़ा decorate करना है, so you can always use a switch, which is a good practice because a switch is a circuit maker and a breaker. So you can do that, right? So 60 watt, 40 watt connected with 220 watt. My first part is already done. Like it is easier as well. Even if this is not asked in the question, I should do this as a practice so that I have more clarity with the question. Second is calculate the current drawn in this. Now this is a parallel circuit. For the current, we first have to know the R equivalent. And for the R equivalent, which formula of power we are going to use? Because we know power, we know voltage. Which formula of power will you go with? Come on, quickly. Very easy, ma'am. We can simply use this formula. Can we? Anoop sir, can we use this formula? Can we directly apply? Anoop sir गायब हो गए. वाह, Anoop sir ये क्या हो रहा है? मतलब
I've been sitting for past 2 hours now. I just took a break. I just wanted to go drink some hot water.
Just 5 more minutes, sir. You have done it. The kids have skipped 2 hours.
I've been.
Done the motivation.
I wish you were here before it, so I could have taken some rest. But it's okay. Go ahead.
Definitely. So what about this? P is equals to VI. Can we directly put into this formula? I'm just asking. I'm very curious. Can we directly put into this formula?
What?
Yes
Okay,
no?
you're asking me. All right. Calculate the current drawn from the. I was reading the chat. Calculate the current drawn from the circuit. Yeah. Sorry, what? You're supposed to do what?
Can we directly use the formula P is equals to VI? Can we just do that? That's one of the questions that I also have in my mind. Like, can we just go directly with using P is equals to VI, because we have to tell the current.
Yeah, I mean, I think if it was me, I would calculate the total power first, and then use the, because they've already given the potential difference also. So you calculate the total power and then.
दोनों तरीकों से solve करके देखते हैं which will do better. So kids are saying directly, ma'am, P is equals to VI use करो. Life is so easy. So we have 60 watt. VY is 220 into I1. Let's say this is my first bulb. And 40 watt. This is also 220 into I2. This is we are saying the second bulb. So let's begin connected this way. Total current निकालना है. Series है या parallel है? Parallel hai, so it will be two different currents. So we have to add I1 plus I2 at the end to find the total current. This is, kiddos, your way. And I'm not saying this is right or wrong. We are going to cross check right away. Okay? Now what I would have done personally, because I need to be 100% sure what I'm doing correct, because that will matter. So talking about, first of all, I know the power of first bulb is 60 watt. My circuit is a parallel circuit, so power is V square upon R. I can do this, right? So ideally 60 is 220 into square upon R1, where I will try to find my R1. That is what I would do, because I need to find R equivalent to be more confident with my question that V is equals to IR. Finally, using Ohm's law, how I'm going to find the total current. So if I know the total voltage is 220 volt, I know the total resistance which I'm trying to calculate here, I will be totally confirm what will be my total current. So this is my R1. R1 will be given as what? 60 upon 220 ka whole square. I'm not going to solve this. I'm not going to make my life difficult. Don't worry. For the same, if we do the R2, R2 will be what? 40 upon 220 ka whole square. This is what it is. Now, if they are in parallel, let me choose a different color so that now we can go. So this is one R1, this is your R2. So if we just go with the parallel में R equivalent, two resistance, 1 upon R equivalent is 1 upon R1 plus 1 upon R2. Let's put in that. If we do that, what will I get? 220 ka whole square is going to be there. Now let's take it as a common thing, and I have to add 1 upon 60 plus 1 upon 40. Will that do better for me? It is something that I am more confident about for this formula. Let's get to the next sheet, sir. Let's see whether the kids' idea is better or my idea is better. So
unfortunately, there's lag again. Every time. laggy again.
There's still a lag?
Yeah, there's still a lag.
Okay, it might be. It's okay. So yeah. So talking about this, your method turns out to be the better method. So talking about your method, if you can directly employ, do not get fussed up in the long calculation and got confused. So here P is equals to VI, you are most probably correct here with two powers, two I currents, and the total current will be the sum, as you guys have told, and that's amazingly good. Amazingly good that you guys are very, very confident about the method you are going to employ in your exam, right? Talking about the last part, sir, let's go to the next part. The last part of the question was to find the total energy. So next sheet will be here. So the total energy consumed in 1 hour by both the bulbs will be, the energy will be power into time. Now power of what? Power of the two bulbs we have. 40 watt and 60 watt. Simply multiply it by 1 hour and we get the answer. Now it's better to write the answer as you like. You can give the answer in joule. That is perfectly fine. But as the power was in watt and it is asked for 1 hour, it's better or it's smart move to give the answer in the commercial unit. Okay, bachcha? So if you can kindly use the commercial unit, that will definitely give, save you time as well, and it will put a good impression of yours as well on the examiner ki bas bacche ko sab aata hai. Okay? Because there is a sheet. They do not know you personally, they do not know your roll numbers, even they do not know your name, school, city, nothing. What they know, what you do in the paper. So the last minute thing that I would say, make the best of impression there and try to put your best foot forward. Okay? That's it. I guess this is the last question that
that was the last question. That's it. All right, people. So I think we'll call it a day now, because you also have the marathon series of Pritesh sir starting right now. So once again, thanks a lot, people. I hope there's a lot of lag also happening, but I'm really sorry for that. But yeah, I mean, for now, that's all from our side. Thanks a lot for joining, people. All the very best of luck. Rock it. Stay confident. Stay calm. That's more important. Please be calm. And once again, I want to say this. While you're going to give your exam tomorrow, make sure that you, again, the only request is this, that please stay calm and make sure you remember this mantra that you will breathe no matter what. No matter how, even if the first question is hard and you feel, demotivated immediately, or if you feel like, it's not what you expected it to be, but still take a breather, relax yourself, because even if the first question is hard, does not mean that the whole question paper will be. Just stay calm and give your best. You have spent 1 full year on this, right? 1 full year of your life you have dedicated for this now. So make it worth it, right? And good luck. Rock it, right? Let us know how your exams turns out to be. We'll all be waiting for your answers. In fact, we are also more anxious than you guys. We are actually more anxious than you guys to know how it becomes, or how it turns out to be. So we are also waiting for your results. Let's see how it goes. But again, be confident. Just make sure that you guys perform your best. All right. So that's it. Take care of yourselves. Bye for now. Take care. Enjoy yourself. Have a great evening. Good luck. Any last word, Bhavna Mam? Any last words that you would like to say?
All the best. Give your best. Everything rest will happen on it.
Exactly.
Right? Take care, bacha party. Exam code karana.
Yes.
Bye-bye.
We will take care. All the best. Go join your biology session now. Peace. Bye-bye.